Oh, yeah. Gotcha. Yeah, with my Graviflyer stuff, it's nice, man, because you'd be able to go and do a test, give them live updates, and they don't have to pay for the extra stuff from YouTube. Oh, right on.
Never really know what's going on. Look at me sometimes like all you want to do is run. Hear me out, hear me out. It's all the things you never show. There are the things I want to know. Secret stars
This video was bang on brilliant stuff. I'll give it a shout out in my next video. I've forwarded it to Malcolm to check out too.
The viewers have spoken.
What an amazing documentary. Thanks for producing it.
Never seen this all tied together so well. Gonna share the heck out of it. Bravo and thank you.
Divine Science is officially a hit.
Amazing stuff, very nicely presented. New sub who can't consume your content quick enough. Great video, dude. Keep at it, you are doing the good work.
You did a great job putting this all together. It's a great overview, goes into amazing depth at times, so it's interesting for the larger swath of people. Well played, sir.
Okay, so I didn't sleep last night because I watched this 3 times and binged the rest of the channel. You have fantastic instincts for piecing concepts together. Almost every section was something I was already familiar with in a different context, and this documentary was the thread connecting them all.
Join us on a journey into a place of hidden knowledge. A place where science is stranger than fiction.
Get the camera set up. There we go. Hello everybody, I'm the Benefactor, an independent researcher, and I'm here with Nathan from Old Man Builds, and we have a very special podcast for you.
Hey, how you guys doing?
All right, as always, you can follow along in the link in the description with my presentation here. We are streaming on Rumble now, so I'm not quite sure if the description links carried over to Rumble, so if you would like, you probably need to head over to the YouTube description to get that link. All right, and if you guys aren't aware, Nathan from Old Man Builds is a very talented engineer, and he's working on Graviflyer by, I think it's Alexi?
Yes.
Real quick, would you like to tell us a little bit about that?
Well, everything's going good. I haven't been able to work on it for the last couple of weeks. We're doing a study into Tesla coils, and I don't have mine up and ready yet. The problem is I need a circuit that has 2 power sources, one that's average power and then one that's immediately high power. Instead of waiting for feedback to go into my coil, I'm just going to bypass that and hit it directly. So it's a little bit of an effort to figure that out. And thankfully on my channel, I've been working with Sean to get that done. And hopefully in the next week or so, we have some good results, post a video, and then it's back to testing.
Awesome. That sounds awesome. And I know a lot of the roadblocks that we've been trying to overcome in these projects that we've been working on. One of the reasons why I'm uploading and doing these presentations from the Practical Guide to Free Energy Devices is to try to see if there's anything in there that could help us out. You know, something that could give us a hint as to where to go next or how to solve our problems with our projects.
Yeah, I think the same thing. Sometimes you run across something, you don't know what to do with it. Takes a little while to set in your head before you come up with the right idea.
Right. And there's a lot of good stuff in here. that I couldn't keep to myself. I had to share this with everybody because it's invaluable stuff to me in my research. So
Yeah, I find that with like old timers, and they talk about their UFO projects they were working on, and just the way they describe it, move in and out of energy, and the way that they do things, it's so helpful because if you can start seeing that in your project and where you're at, man, it's like easy to zoom in on it and really get a good idea of what they're trying to get accomplished.
right, like if you have a good foundation of the real science, because right now our science is like, what is it? It's probably like 20% of what the real picture is, if even that. So if you can get a more accurate science or foundation of science, which is what this guide, I think, has a lot of the more unexplained phenomenon that, we just don't touch on in mainstream science, like ball lightning phenomenon and cavitation and cold electricity, stuff that's considered fringe science. These people take seriously and they study it seriously. And I think that's a main contribution here is taking some of those fringe subjects a little more seriously.
Oh, just getting the corporate BS out of the way. I'm sure there's regular physicists and stuff that work on these things in private, and they don't share it a whole lot.
Correct.
But the corporate mainstream people are just a disaster when it comes to this.
Yeah, and it's funny because I think to myself, when you're in like a black budget program or one of these high up industries, like aerospace industries that have all these top secret projects they're working on with new antigravitics or whatever, they have to go into it. And I think to myself, the first thing they have to teach these engineers and scientists is okay, the aether is real, the vacuum energy is real, and how do you harness that? And once you have an idea of like, okay, the aether is a real phenomenon that we have to include in our variables, then you start thinking about magnets differently. It's not just magnetic lines of force that can't be explained. It's a pressure differential in the aether that's creating a current, and it can all be explained.
Yeah, well, not just that. A lot of people think magnets are the end all be all, but if you look prior to the magnet, you get a charge. And
Right.
the charge establishes itself before the magnet. So you have to kind of break down voltages and stuff like that and understand what part you're really looking at here. Because if you understand voltage, you can manipulate it in any way you want. If you don't understand it, you'll think that, you could just go around and just do watts on everything and be completely lost because a watt's one number times the other gives you the watt. So 1 times 100 is still the same thing as 100 times 1, but the electricity is on total opposite ends of the spectrum. So
That's interesting to consider. And to me, it all seems like different modalities of the same phenomenon. Like how you see electricity and magnetism are basically the same thing, only, if you know how they work and how to manipulate them, you can isolate those components.
well, yeah, I created a chart on my page, and I went through and showed the difference. When you take away a little bit of electricity, you're going to be adding a little bit of amps into it. But when you do that, you're also changing the frequency in the voltage itself. Now, that right there will create a temperature difference in the actual voltage itself. So you got several things going on. Now, then you just turn that dial a little bit, and you're going to have another factor come into play. So whether that's charge, whether that's magnetism, depending on the material you're working on, there's a lot of different factors that go into this, and you don't realize that they're there. And then when you do, you have to identify and parcel them out. So it's like I said, like a watt, right? So if I put 1 volt in and I put that by 100 amps, right? I'm going to get a magnetic coil. And you're going to go, okay, well, that makes sense, right? You got a lot of amps, got a magnetic coil. But if I switch that and I put 100 volts in and I put 1 amp in, now what I get is a spark gap energy, right? And I can create a laser out of it. So two totally different ends of the spectrum, exactly the same wattage.
Interesting. And it's just the understanding that that scientific principle, like you said, you can manipulate it. You can isolate those components and manipulate them as you see fit, instead of just trying to determine, what the heck is going on and trying things at random.
Yeah. It helps. Like the one thing I told you last time on Free Energy Friday, we looked at that little device with a little frequency and duty cycle. Big game changer when you get into this, especially when you want to just get to the charge of an item. Man, you can rip out so much stuff from that and just get the pure charge of something. It's amazing.
So explain to me what duty cycle is.
Duty cycle is just like your pulse rate. So
Okay. So your frequency.
basically, if you run a motor, you know what I mean, you got a PWM signal when it turns on, when it turns off, stuff like that. So that's your duty cycle. It's a pulse rate. So basically, anytime you do that, you can speed up how fast it goes or how slow. But when you do that, you're backing up voltage into the driver, and then you're going to explode it out. So you can actually pull the spark gap further apart and get a nice spark out of it if you can change the duty cycle.
So increasing the duty cycle would increase that spark gap distance?
Decreasing it.
Decreasing it. Interesting.
Yeah, because you want to build up the energy in the driver. The driver pushes like a freight train. It just keeps going, right? And then if you hold it back a little bit, it'll hold the power in the driver, and then you let it release. Every time it releases, it can shoot a further distance because it has more power built up.
Oh, like a spring load. Oh,
Yeah,
that's
just
interesting.
like that.
Yeah, that's cool. All right, so let's start with the cold electricity from UFO politics. I think you guys will find this really interesting. There's a lot here. I don't know if we're gonna read all of it, but again, it's all publicly available if you want to go through it on your own time in more detail. So a man who uses the forum ID UFO politics, and we've actually gone over a couple of his forum posts before, a very enigmatic character, has been sharing his insights and experiences on various different forums, such as the one dealing directly with the production and use of cold electricity in solid-state circuits. And there's a link here that if you guys want to check it out. I haven't checked out any of these links. They might work, they might not. This is 2017 edition, so this is 7 years old. So his insights are unusual and very important. His basic statement is that if a coil is pulsed using a circuit like this, you see we have a hot coil and a load coil, and in a fast recovery system with a couple of diodes and looks like switches. And then conventional hot electricity pulses the coil when the transistor here, I believe that's the transistor, right? Switches on. But if that current is switched off rapidly, then there is an inflow of cold electricity into the coil from the surrounding environment, 0-point energy or whatever. That inflow of energy can be collected and diverted to power a load through the use of two high-speed diodes which carry considerable current as the power inflow is substantial. This reminds me of what we were looking at with the Bedini circuit. How he just uses simple circuitry to kind of like tap that vacuum energy.
You're just using high frequency diodes there to bring it over, but it has to have a load to draw it. So they tell you to use a light bulb in there with a fluorescent, or not a fluorescent, I'm sorry, the little wire that goes across.
Yes.
Anyway, you need filament, that's what I think it's called. Anyway, you need that in there, and it has to pull the energy in. If it does not have that, you will not get the cold energy. It'll actually bypass the circuit and go back to the hot side.
Interesting. That's awesome. Yeah, exactly what it says. It says, in other words, a low percentage duty cycle for the transistor. There must be a significant load on the cold electricity output. Yep. If there is not, then the cold electricity will flow back into the hot electricity section of the circuit, and it may damage the transistors. Interesting. Tom Bearden
Well, yeah,
states. You said what?
Go ahead.
No, go ahead.
Yeah, well, the transistors work on a principle of voltage versus amps, and when you destroy them, it's because you allowed heat in the system. So when you put heat in anything, say if it's 230 volts and it's 15 amps, but then you introduce heat, right? Heat will degrade your voltage level you can go to. It'll also degrade your amp level. So you'll have a lower tolerance on both. So if you heat it up a bit, you can lose 50% of your volts and 50% of your amps immediately by just going, 3 degrees and not being able to cool it. And you'll just explode your whole MOSFET or transistor or whatever you're using.
Right. That's very important to consider, I think. Tom Bearden's in here, it says Tom Bearden states that resistors boost cold electricity rather than hindering its flow. Like, they usually resist electricity. So the load should be a coil, a DC motor with brushes or a fluorescent light bulb, like you said. Interesting. It has been observed that the income energy tends to flow inward toward the center of the coil. So an additional method of collecting this energy is to place a second coil, like a secondary coil, to the main coil and wound it in the same direction like this. Okay, so here's another diagram for us to look at. It looks like it looks like we got cold electricity flowing in two directions here. This is the secondary coil wound inside the primary coil, it looks like. This provides two separate independent cold electricity power outputs. Diodes are not needed for the inner secondary coil. This inner coil is a pickup coil and is not related in any way to the number of turns in the hot electricity pulsing coil. Instead, this coil collects inflowing cold electricity during the period when the pulsing coil is switched off.
That makes sense.
Like a suction cup, it's pulling something. Yeah. Wow.
But it has to have a draw. It has to have that load on it to pull the vacuum of it. To get the energy to flow.
Oh, wow. This is starting to really make sense. Holy crap. So let's continue. Instead, this coil collects inflowing cold electricity during the period when the pulsing coil is switched off. The hot electricity pulsing coil can be wound directly on top of the extra pickup coil, or the extra coil can be wound separately and placed inside the main coil spool.
If he says sorry, let me interrupt you.
No.
If he says it's when it's turned off and you get the cold energy, just understand that every time that you have the primary coil on, it's producing heat along with a magnetic wave, right? Or a magnetic frequency, however you want to say that. It's creating a magnetics, and that creates heat. So when you turn it off, it gets cold, but then there's that energy still there that's in the air, and you're pulling it in, and you're taking it.
I got to ask you something. This is this same phenomenon where it's like kind of sucking the vacuum energy in while it's switching off. It kind of reminds me of Joseph Newman's pulsed magnetic motor, where we believe like he's pulsing it on and off. And there's like this known phenomenon where you get like a quick spike in voltage on when you sharply turn a motor off. I believe it's some kind of magnetic motor, or it could be any motor. But you know what I'm talking about? Where you sharply switch it off and there's like this quick spike in voltage.
Yeah, you usually get a pulse at the end, yeah.
Yeah, I want...
It's like a buildup in your circuit, like we were talking about earlier. Anytime you deal with that, remember, you can back up that circuit pretty good. If there's no area for it to flow in one of the three channels, say it's a brushless DC, it'll find one of the channels and flow. And then you get a spike
Mike.
in one area.
That's interesting. Mike says, "What's up, Nathan? Was researching was researching ZVS again late last night." You said what?
I said I.
Oh, the caps serve the function of rising voltage slowly and dropping slowly. Interesting. Yeah, this cold electricity. Oh, hey, misunderstood. This cold electricity is very interesting. Let's continue on.
If you look at Gerald's device, and I'm excited for tomorrow, he's got geometry going on there. So like when it comes out of the capacitor, it's at a higher rate than it is when it continues down the line, right? Because he has that spike.
Right.
Now, when you put multiple coils together and you get that spike, remember it goes through all the coils. So you have a discharge coil, which is your primary, and then you have a secondary pickup coil. By using that geometry, he's able to amplify at points like all the way around like slices of pie, okay? So it's really awesome when you could take that thing that normally people would try to weed out of your device. He's multiplying energy with geometry. And like you do with your coil, how it has flows of energy, you got to understand the flow. If you can understand the flow, hitting the capacitance to that flow, you're going to be able to just take your energy and you know what I mean, drive it up.
That's interesting. Yeah, it's all about the geometry, it seems, and understanding the geometric principles of your system. And, you know, every system's different, but you know, even the geometry of the circuit itself, you know, like choosing the path of least resistance and not letting the energy, you know, dwindle in one area or another, I think is very important to consider as well.
Yeah, well, it's like your coil, right? You got the rod and coil. Where they cross, you want to put a pulse right there, okay? So if you take a duty cycle and you reduce it, and you get it where you can find the individual pulses where they cross, you get an amplification point right there, right? So you're going to pulse every time it hits there. Now, if you can get that coming over the cross, that means that your pickup side gets a lot more energy than it normally would. If you miss it, you go before it or after it, you're going to get a lower amount of energy. So if you understand the energy flow of things, it's not hard to amplify, but you also got to be able to put your meters in the spot where it can read it.
So are these coils that he's using, are they, is he resonating to load too? Is he using like a resonant circuit as well?
So he puts it in the megahertz, right? So just understand this. Like I told you earlier, when you change the actual frequency of something, you're going to change how the voltage and amperage works. So not only is he using the geometry, he's using the frequency to change the actual variables in it.
And that's very high, the megahertz. Holy crap.
Yeah, but he can control the heat that way. You're going to get less heat, so you're going to get more benefits out of it than you would it with the heat, because the heat's just lost energy. That's like money out the door. You don't want that. So he reduces that by putting the correct frequency in. And the frequency is based on the coil size and everything else. So we wouldn't be able to guess his number unless he tells it to you. You know what I mean?
Would you think that the frequency or the resonant frequency is just based on the primary coil, or is he considering everything that's hooked up after the primary coil as well?
Let's put it this way. Do you know the difference between resonance and resident frequency?
No, I don't.
Okay. So when you have two frequencies pulsed right close to each other, right? And then you add a pulse to that. So you're bringing the frequency wave up, bringing another one up right beside it, right? Just like this. And then I pulse it. I get a resident frequency. I get the maximum value that frequency could give me, or the maximum resonance, right? So it's like when you strike a bell. You hit the side, and then you stand away, and it vibrates, right? But the moment that it has the most energy is the second that you struck it, right? So that's like a hitting the side. It's like adding the pulse to the vibrating bell. So you get an amplification of energy.
Let's see. I was going to continue on with this page here. There's a lot of technicalities, but it looks interesting to get into a little bit. Because it says, very surprisingly, it recommended that the powerful high-speed diode used to channel the cold electricity out of the circuit be followed by a small 1N4148 silicon exbiaxial planar high-speed diode. I'm not even sure what that is. 75 volts, 0.45 amps, as this is said to clean up the cold electricity output even more. I'm assuming, yeah, because a lot of these devices recommend some method of cleaning up the signal, just because of, I guess, how bouncy it is with the high frequencies, I'm assuming.
It's like a Tesla coil snubber circuit. That's the diode I believe they're talking about there. That's the one you need.
So it's the same one that you would use in a Tesla circuit, a Tesla coil.
In the snubber. Yeah, in the snubber. To deal with back pressures.
And that's, is that the LC circuit?
You could use it on a Slater exciter. Yeah. Which one are you talking about, the LC circuit? I'm kind of lost.
From my knowledge, the LC circuit is the resonant circuit, or the circuit that produces the resonance in a Tesla coil. I could be mistaken, though.
Yeah, but a lot of circuits create the resonance. I mean, it's an oscillating circuit, so you can use a lot of different drivers, man. More than you think.
So there's a lot of different methods to applying that frequency.
Yep. Like I use a ZVS and I use a Slater exciter. I think there's DDRT or TC, DDTC. I'm not familiar with the acronyms for it, but there's like a lot of different ones where you can do half wave, full wave, bridge, you know what I mean? And control this. I generally stick with the easier ones, you know what I mean? That I can manipulate just slightly.
No, that makes sense. You know, you want to keep it simple, stupid, like Malcolm says.
Hey, look, I do a project where a lot of people get involved on how to build something. The best thing you could do is make as much general information possible that you can. Because if you got into where I got into, you'd be really deep in the woods of this thing, man. You'd be out there with your oscilloscope. You'd be out there with your multimeters. It would take you days just to understand one circuit that I put together for this thing. And it's an exotic circuit. But in testing, I try to use general circuits. You know what I mean? So that everybody's like, okay, a couple solder points, we're good to go. We can all participate.
Yeah, I think keeping it simple is best for if you want to try to have people replicate it and see if you know, you're trying to verify something. But as you said, more exotic circuits could probably manipulate the device a lot more accurately, I imagine, right?
No, yeah.
Yeah.
If we're talking about changing voltage in any way, man, the changes I can make to some of these circuits on the, you know, like the flyback circuit, I could completely change how that works. And depending on which way I want to go, people always tell me, hey, change the material, you can get more of a magnetic value. Well, I don't have to. I just have to change the circuit a little bit. That's it. You know what I mean? I don't have to do that. I know how to manipulate the voltage to get that. So like I have a project that I work on that just deals with charges. It's high voltage, but I'm not using any of the high voltage. I'm taking the air itself and charging it inside of a piece of paper and having it create a weight that pushes down with force.
Mike asks, what circuit are we looking at here? So right now, we're looking at UFO politics cold electricity circuit. There's a couple of different diagrams we have. I believe they're different diagrams of the same circuit, or different. No, this is a different variation, I believe. Where the secondary coil for the load is actually inside. Yeah, no, I think this is the same diagram, just different perspectives. So it says, there is one additional thing to be done with this circuit when a DC output is required, and that is to apply filtering to the output, like we were discussing. You know, you want to filter the signal because it's going to be very unstable and bouncy. First, when the energy has passed through the NTE 576 or equivalent power diodes It encounters a high frequency, low capacity, high quality film capacitor placed across the output in order to siphon off any high frequency voltage ripple before it is passed through the small 1N4148 diodes and into a smoothing and storage electrolytic capacitor. Sorry, I have a problem with that word. Storing the cold electricity, and the electrolytic capacitor converts it into conventional hot electricity. And here we have another diagram of it. We're going to take a quick break here in a minute. Just a heads up. I didn't intend to take a break this quick, but we're going to take a quick one in about 5 minutes. Let's see. While this circuit looks like something which you just switch on and it works, that is not the case, as there is an essential startup procedure where the signal applied to the transistor is started at just a few cycles per second, so it's very low frequency, and at 50% duty cycle. And that input is then adjusted carefully and slowly while monitoring the voltage and currents produced by the circuit. This is a seriously powerful system with the capability of producing a major power output. So it sounds like they're kind of driving up the voltage by using...
triggering the MOSFET.
Yeah. And the MOSFET, explain to me what a MOSFET is.
So it's just like a transistor, basically, except for it has different values of where it turns on at. So it could be like 5 volts turns on the MOSFET, right? And it allows energy to flow. If you don't turn it on and you just go straight to a higher voltage, it won't work right. So you got to trigger the MOSFET. So what you do is, and this happens in the ZVS Tesla coil as well, you put in a small power source, right? Anywhere from 5 to 12 volts, and it triggers the MOSFET to turn on. Now your energy flowing is correct. Now it goes to the right places it's supposed to go. Transistor does it automatically. A MOSFET doesn't. Trigger it, turn it on, and then you're good to go. If you don't, you're not going to run your circuit properly, and it's going to try to put the carriage before the horse, if you know what I mean.
Right. No, that makes a lot of sense. I like that analogy. So I'm just going to finish up this page here real quick before we go on a quick break. It is very important that the circuit is not powered up without a suitable load on the cold electricity output. A suitable load is a self-blasted 230 volt fluorescent light. It must be understood that just flipping the power switch to its on position is not sufficient to get an inflow of cold electricity. Instead, it is necessary to progress the start-up sequence carefully, and a fluorescent light is particularly helpful for doing this, although a neon bulb is also a popular choice for temporary load, because these devices allow the current flow in the load to be assessed visually. Yes, yeah, I always go for any kind of visual confirmation if possible.
Yeah, let you know it's on.
Right, right. And it sounds like it's kind of like, I don't know if it's necessarily tuning it, but it's kind of winding it up, you know?
It gives it a draw.
Right.
It's pulling it. You have to have the pull.
Yeah, as we were reading before, the pole pulls in that vacuum energy, that radiant or 0 point energy, as the electricity turns off.
So just think of it as the path of least resistance. So if you don't prime the path to go one way, it won't go there because it'll go the path of least resistance, which is the heat side.
Right,
so
right.
You have to create a pull in order to create that path.
Before switching on the input oscillator, it is set to 50% duty cycle and minimum frequency. Then the frequency is raised very slowly, causing the lamp to start flashing. As the frequency is raised, the current draw from the battery needs to be monitored as it is current flowing through the transistor, and the current is kept down by lowering the duty cycle progressively. This process is continued carefully, and if successful, the color of the light produced will initially be purple or green before reaching continuous bright white light. Videos showing the light produced and the fact that it is not dangerous to life or affected by water can be seen at. That's interesting, because I don't think traditional fluorescent light bulbs turn purple or green before they turn bright white, right? Not to my knowledge,
No,
at least.
I usually see like a yellowish.
A yellowish.
Yeah.
So you think that has something to do with like the cold electricity affecting it?
It could just be the light bulb they're using.
Oh, the neon light bulb, maybe. Interesting.
Yeah.
Well, we do know that cold electricity needs to be accounted for in your output, circuitry or whatever, due to the fact that, it affects components differently. Like I was saying, I'm pretty sure that it's lowering the temperature, or I'm sorry, raising the temperature of the fuses in my multimeter. So that could throw it off a little bit,
Cold energy is cold.
Yeah.
It's removing the heat.
Mm-hmm.
So you're running the heat circuit on one side and the cold energy on the other, so you have hot one side, cold the other.
Yeah, it's interesting, because there's just different variables you have to consider with that cold electricity rather than a hot. Like, I guess, we were reading Tom Bearden says that resistors are like basically they act opposite. They help accelerate cold electricity instead of resisting their flow, which is wild, right?
Yeah, it's interesting. I don't do a lot of work with cold electricity, but that's interesting.
Yeah. Well, closing up real quick before our break, driving force is a series of powerful magnetic pulses, and implementing the physical circuit to achieve that requires careful construction. The battery driving the circuit is a 36-volt combination of cells. The coil is wound as an air coil construction on a 2-inch or 50-millimeter diameter spool, and the DC resistance is arranged to be about 1.4 or 1.5 ohms. This, in turn, requires a substantial drive from the transistor, and so it is normal to connect 6 powerful output transistors in parallel in order to spread the current flow between them, as well as dissipating the heat generated across several transistors bolted to a common heatsink of generous area. How the coil is wound is something to consider. The objective is to have a coil of about 1.5 ohms of resistance, and which has maximum magnetic effect for the current passing through it. Copper wire has become very expensive, and so it would be very costly to wind the coil with vast lengths of thick wire, not to mention the very large size and great weight which would be produced by doing that. Yeah, it's going to be a really heavy coil. The copper wire options in Europe are typically to work with half-kilogram reels of wire. Details of some of these are as follows. I'm just going to put this up here real quick, and we're going to take a quick break, maybe 10-15 minutes, and we'll be back with some more from the Practical Guide to Free Energy Devices on our podcast with Nathan from Old Man Builds. Can you hear me? Oh, okay. Yeah, so I gotta go pick up my girlfriend is at the laundromat, so I gotta go pick her up real quick with the laundry, and I'll be right back. Yeah. We can turn off the camera like that, and the microphone, all that. Yeah, it's cool. All right. Nice. All right, dude, I'll be right back.
I need your absolute attention for a moment. Please, pay attention to the video you are about to watch and see if you can notice the problem.
It's an interesting character for me. It's not necessarily somebody you'd think that I am right off the bat be playing. A lot of people say, you could play Truman. Sure. But it's like, it was a tough job for me.
Did you see it? Some of you might have even seen it, but don't know how to describe it. What you just witnessed was a micro-expression, and even though it only lasted a fraction of a second, it could tell us everything we need to know. A moment of contradiction between emotion and words. Robin Williams' last video interview was with The Talk in 2014. In the interview, he discussed his new show called The Crazy Ones, and shared some stories from his past. Here we see Robin in a moment of what appears to be slight joy, talking about playing Truman, and then a flash of extreme sadness. And it doesn't just happen once. These are clear patterns of behavior that are universal. Have you ever wondered what someone is thinking? I'm not talking about those sideshow scammers you see grifting in the strip malls, preying on the desperate. I'm talking about a way to really know what someone's truly feeling. If we were looking at the world through the lens of Dr. Paul Ekman, maybe we could have spotted this contradiction. Eastern Highlands Province, Papua New Guinea. A mountainous region of the Papua New Guinea highlands, between the upper reaches of the Ambulum and Okapa rivers. Dr. Paul Ekman, a renowned psychologist who specialized in the study of nonverbal communication and facial expressions, is just finishing up his second year studying the facial expressions of the four people when he reaches a startling discovery. From 1967 to 1969, Dr. Ekman was interested in their facial expressions and whether they were universal or culturally specific. He found that the four people had the same repertoire of facial expressions as people in the Western world, which further supported his theory that facial expressions and emotions are innate and universal. This research with isolated tribes helped him to further refine his theories and develop his understanding of how facial expressions work, which has been invaluable to his work on micro-expressions. Dr. Ekman recorded their interactions and studied their facial expressions while teaching them how to read emotions from Western faces. His work with the four people helped him to develop a comprehensive theory of micro-expressions called the facial action coding system. Micro-expressions are subtle, fleeting facial expressions that occur within a fraction of a second and reveal a person's true emotions or feelings.
There are two kinds of facial expressions, a macro or normal expression, which comes on and off the face usually in 2 to 5 seconds, and a micro expression, which goes on and off in a 25th of a second. Now, if you use slow motion or freeze frame, a micro expression looks just like a normal expression, but it's been compressed in time. It's an attempt to conceal true feeling.
These expressions can occur when a person tries to conceal their true emotion or feelings, and they can be a reliable indicator of lying or deception. Micro-expressions typically last for a fraction of a second and are often difficult to observe. However, with practice, it is possible to develop the skills to identify these subtle expressions and understand their meaning.
Here is the really interesting thing about Paul Ekman. I'm scared to be around him.
Yeah, I was very kind of paranoid when he was around.
You just assume that he is going to just like peer right into your soul, and he's going to basically give you a printout of all of your bull.
To spot a lie using micro-expressions, it is important to look for inconsistencies between the person's verbal and nonverbal behavior.
Colleagues have touched on counterfeit goods, and I share their concerns very deeply. I'm also concerned about stolen goods. Mr. Bezos, are stolen goods sold on Amazon?
I just said with over 1 million sellers, I'm sure that it has happened.
For example, if someone is saying one thing but their facial expression suggests something else, it could indicate that they are not telling the truth. There are different types of micro-expressions, each corresponding to a different emotion. The 7 universal emotions are happiness, sadness, fear, anger, surprise, disgust, and contempt. Spotting micro-expressions of these emotions can be useful in detecting deception. In summary, Understanding micro expressions and how they work can be a powerful tool in spotting lies. It takes practice to become skilled in identifying these subtle facial expressions, but with time and effort, it is possible to develop this essential skill. Dr. Paul Ekman's theory proposes that facial expressions are universal and innate, meaning that they are hardwired into the brain and can be observed across different cultures, languages, and ethnic groups. FACS has been widely used in various fields, such as psychology, sociology, and forensic science, to understand the emotions, intentions, and attitudes displayed through facial expressions. You have to realize, the average person lies 3 times per 10 minutes of conversation.
The question is never simply if someone is lying, it's why.
For more information on microexpressions and how to train yourself to become a human lie detector, visit Dr. Ekman's page linked in my YouTube description. For more content like this, like and subscribe to my YouTube and TikTok channels and stay tuned for more. From everyone here at Beneficence TV, we wish you all a very Merry Christmas and Happy Holidays. Expand your minds and subscribe today. With this design, there is a slight smell of burnt air, but almost no sense of carbon emissions when putting your nose directly up to the exhaust. The brilliance of Bendel's design is in its simplicity and ability to replicate natural phenomenon. Further proof that nature is the most efficient energy machine. This is a plasmoid thunderstorm generator gas engine retrofit and industrial engine retrofit. They are proof of concepts for clean and efficient energy. This retrofit will turn any carbon engine into clean and super efficient oxygen factories using only gas for the initial start of the engine. For more details on how the Bendel engine works or how plasmoids are the future of renewable clean energy, subscribe to my TikTok or YouTube channel. I constantly push the bar by introducing you to forbidden and obscure knowledge. Take the red pill and subscribe now. Throughout modern history, there have been visionaries who dared to dream beyond the boundaries of conventional science. Inventors who sought to unlock the mysteries of alternative propulsion, anti-gravitics, and the enigma of over-unity energy. Yet, their stories remain shrouded in shadow. Many of these pioneers, their voices silenced, their visions extinguished. Some vanished into obscurity, while others paid the ultimate price. Suppression, it seems, has been a constant companion to innovation. But recently, there's been a glimmer of hope. A new generation of self-taught, open-minded, and independent scientists has emerged. A collective effort to combat the forces that seek to keep humanity in the dark. People like Marco Rodin, whose rediscovery of vortex-based mathematics is nothing short of mind-bending. They pushed the boundaries of mathematical understanding, opening doors to a new realm of possibilities by describing numbers as physical stationary interstitiary vectors in space-time whose values don't change. Unlike traditional mathematics, where numbers change while functions remain constant, this paradigm shift recognizes that in reality, functions themselves can represent the changing variables, opening doors to a new understanding of mathematical relationships. And then there's Malcolm Bendall, a man with a vision that defies convention. He introduced the plasmoid unified model, a concept that calculates the resonant frequencies of everything from the elements to colors, shapes, and even polarized cardinal directions. But Bendall didn't stop at theory. He applied his unified field theory to a revolutionary concept, converting mass into clean energy. His ingenious design mimics nature's use of plasma, producing colossal amounts of pristine energy. Bendall's vision goes beyond energy. It's about reshaping our understanding of the world and harnessing the very forces of nature to propel us into a new era. As Tesla was once accredited as saying, "Throughout space there is energy. Is this energy static or kinetic? If static, our hopes are in vain. If kinetic, and this we know it is for certain, then it's a mere question of time when men will succeed in attaching their machinery to the very wheelwork of nature." In the shadows of suppressed technology, these visionaries are opening doors to a brighter, more sustainable future. The plasmoid engine, a symbol of hope, innovation, and the relentless pursuit of the unknown. Join us as we delve deeper into the mysteries of plasmoids and the brave souls who dare to challenge the status quo. Here on Divine Science. Stay tuned for our brand new show. For more videos on consciousness, zero-point energy, and other forms of forbidden knowledge, like and subscribe to my YouTube and TikTok channels. What are you waiting for? Take the red pill and arm yourself with forbidden knowledge. Subscribe today.
Testing 1, 2.
Yeah, everything says that it's on. There you go. All right. I think I can hear you now.
That's interesting as well because oh, we're getting a little bit of echo.
Okay, you hear me now? Yeah, sorry, having trouble with this. Got it. My headset likes to take over things, turn on and off, and things like that when it's charged, not charged. It's just kind of a disaster. I should have just bought the you know what I mean? The headset without the microphone part would have never had this problem. I see you in the background and your microphone. I don't see where you're reading that. Are you still on the same thing? The cold energy? No. Yeah. That's not a problem. I pulled it up. Okay. Path of least resistance when you get to the 555 and the 100 resistor. And then if you're looking at the top, you're looking at your MOSFET, you're looking at a diode for back feedback protection. That's on that one. It also tells you in there to trip your MOSFET first to start it up. Follow the white rabbit, huh? Yeah. Down the little hole. Let's go.
Oh, my bad. So I was muted. See, so I'm gonna skip down a little bit. It says here on 199, page 199, there are various pulsing circuits which have been used successfully with the system. UFO Politics considers the NE555 chip to be the most straightforward, so perhaps my suggestion for this arrangement might be a suitable choice. So here we have a more complete circuit diagram for us to work with. If anybody is interested in actually trying this, I think this might be a little bit too advanced for me at the moment, but maybe somewhere down the line. What do you think, Nathan?
That seems like a normal 555 circuit.
555 circuit.
Really not that much to it.
You don't think that's too involved for a layman?
No, as long as you know the pin out, then you're good. Because you're only connected one or two things to it. It's not generally hard. Like I said, if you follow the flow, you're good to go.
Right. So this diagram is just making it look a lot more complicated than it actually is.
It's the difference between being able to read a circuit diagram and do point to point. And I generally, when I build stuff, I do point to point. So wherever I solder is where it goes, right? Makes it easy, right?
Yeah, yeah, I get what you're saying.
These right here, you have to understand a little bit of theory behind them in order to lay them out properly.
Oh, yep. Yep. Following the white rabbit. Let's see. In the UFO politics circuit, it is important to turn the frequency down to its minimum value and set the mark's space ratio to 50% before powering the circuit down. Otherwise, it would be easy to power the circuit up with as much higher frequency than is advisable, and so causing damage to some of the circuit components. So this is just, covering longevity of the components and making sure you don't blow them out, I guess.
It's like driving your car. Hold the brake and hit the gas, you're going to have trouble. Ease into it easily. Instead of holding the brake, you're good to go.
That's interesting. No, I like that analogy too, because that helps me visualize what's going on here. Let's see, what is this? I want to make sure I didn't jump too far ahead here. Okay, so this is going into some of the material requirements for the coil and whatnot. Interesting. We got some actual color pictures. One thing that I do like about the 2017 edition of the Practical Guide to Free Energy Devices is that there are a lot of colored pictures. Yeah, I'm going to skip down, and we're going to go to Stan Meyers. We're going to do part 2 on our Stan Meyers section of the Practical Guide to Free Energy Devices. And we're going to start off with a couple of videos that Nathan sent me, and he said 19 minutes into this one on magnets on attracting molecules. So this should be interesting. Let's check this out.
Looking to build a chatbot for your website?
No.
You can find AI.
All right, skip that. Oh,
hello everyone.
RW
My name is
G
Russ
Research.
Grease,
I like
and
this guy.
today I'm going to be telling you some stuff about Stan Meyers.
Yeah, I can't see it on my end, but I imagine you're playing it.
Yeah, let me see if I can do something about that real quick. Give me 1 second. Do you have my stream up? I can give you the link to my stream. That might help, and then you just mute me in Discord.
You know what? Let me see what I can do here. I have up right now this. I don't know what I have going on, man, to be honest with you.
It's okay. Here you go. I'm gonna mute myself, and you don't have to do anything. I'll mute myself in Discord for you, and then when we're done with the video, I'll unmute myself.
Okay.
Okay. So we got that, and he said fast forward to 19 minutes.
It's the one that's in the book. Carrying out the purpose of vaporizing material into vaporized particles and thereafter magnetizing the particles by subjecting them to a magnetic field. So it looks like Alex or somebody, I believe, has something here that says permanent magnets right here. So as the gases, whatever gases these are, I don't truly think these are just hydrogen and oxygen. I believe this is some sort of a, well, it says later it's like a plasma arc in between these two electrodes, and it's actually like a fog or a steam and hydrogen and oxygen all mixed together. That's what I believe that this is showing, because it's not a standard fuel cell where you've just got electrolysis going on. No, there's an actual like electrical
Okay, go ahead and
gap
pause it.
that must be jumped. All right.
Okay. Yeah, it looks like some kind of ionization, maybe? You said there was a spark gap?
Okay, now show the other short video.
All right, let's load up. This is the oxygen, the magnetic oxygen higher conversion rate from H2O to H and O. Load this one up.
I'm going to try pouring some liquid nitrogen over the poles of this strong magnet to see what happens. Well, that doesn't look like a whole lot happening, except for maybe the magnet getting cold. Well, let's try doing the same thing with some liquid oxygen. Hey, check it out.
Yeah,
The
oxygen
liquid
is,
oxygen sticks to the magnet.
Is it
And it
polarized?
looks like it has a slate blue color, too.
Just watch what
Interestingly,
happens. Okay,
some
so he
medical
puts another
sensors make
material
use of the
there right now,
magnetic
right?
properties of oxygen to test for its
Watch when he
presence in
puts the
blood.
pure oxygen to it.
I'm going to try pouring some liquid nitrogen
Wow.
over the poles of this strong magnet to see what happens. Well, that doesn't look like a whole lot happening, except for maybe the magnet getting cold. Well, let's try doing the same thing with some liquid oxygen. Hey, check it
Wow.
out. The liquid oxygen sticks to the magnet.
So, okay,
And it looks like it has a
let's
slate
discuss it
blue
for a
color,
minute. We
too.
good?
Yeah, that's crazy. Look at it.
So just understand this. In Stanley Meyers, he's separating oxygen from hydrogen, right?
Right.
And we just played the part where the guy said he has this little magnetic coil area where it's attracting something, right?
Right.
So now you look at it and go, okay, he's attracting the pure liquid oxygen right there. Therefore, only
Oh.
hydrogen passes. So
Wow.
you're removing it. So the first thing you do is when you put this circuit into place, you're going to break the hydrogen and oxygen, right?
Mm-hmm.
Now you're going to attract the oxygen away from where it is.
Right.
Then-
And it's just going to be the pure oxygen. That's awesome.
Pure oxygen there because it's attracted to it, but the
Mhm.
hydrogen is going to come out. Now you're going to get hydrogen coming out without oxygen.
Right. So it's like a filtration system.
Exactly.
Wow. That's effing cool, man. That's cool as heck. I like that.
It makes more sense now, doesn't it?
It does. It does make a lot of sense. And there are these key ingredients to Stan Meyers' inventions that he left out that I think we're starting to piece together, and it's really cool to see.
Yeah, if you know the science behind it, you can recreate it. If you don't, it's like an uphill battle sometimes.
Yeah, Stan Meyer. He was so smart. He was so brilliant. He had I think it said it's a little spoiler, but in the chapter that I'm about to read, I think it said he has 40 patents. So that's that's pretty impressive. That's pretty cool.
Well, just think about it. They're not so much a giant patent for everything. You know what I mean? You have to individualize each part when you build it. And then you patent each part. So some of them might be a bigger design, but there's a lot of small little things in there.
No, that makes sense. You don't just patent the water-powered car. You patent the fuel cell, and you patent the different electrical component mechanisms. That makes sense. So Mike says hydrogen is proton-based and oxygen is electron-based. There you go. There you go. And electrons have negative charge, as we all know. That is so cool, though. I just want to watch this one more time.
Interestingly, some medical sensors make use of the magnetic
it's a cool
properties
effect,
of
man. I
oxygen
like it.
to test for its presence in blood.
I'm going to try pouring some liquid nitrogen over the poles of this strong magnet to see what happens. Well, that doesn't look like a whole lot happening, except for maybe the magnet getting cold. Well, let's try doing the same thing with some liquid oxygen.
Hey, check it out. The liquid oxygen sticks to the magnet. And it looks like it has a slate blue color, too. Interestingly, some medical sensors make use of the magnetic properties of oxygen to test for its presence in blood.
Cool. Awesome. Moving on to the chapter that I found regarding his electrical particle generator. I think you guys are going to find this very interesting because, I mean, it from the looks of it and how it sounds like a very easy system to replicate. It doesn't sound too involved, which is why I wanted to talk about it. So there, you know, if you're following along on the guide that I provided in the YouTube link description, or description link, there is these pages that contain links. I'm not sure if they're active, but you can always try them. I'm not about to try them right now because I'm going to continue on with this chapter on the electrical particle generator by Stan Meyer. It says Stan, who is famous for his water splitting and related automotive achievements, actually held about 40 patents on a wide range of inventions. Here is one of his patents, which circulates magnetic particles in a fluid, and while the fluid does move, none of the other components in the device move, and a high level of constructional skill is not called for. This is a highly efficient generator of electricity. This is a slightly reworded excerpt from the Stan Meyer patent. Although it does not state it in the patent, Stan appears to make it understood that this system produces a significant power gain over unity, something that patent offices find very difficult to accept. And that's worded weird. Electrical particle generator. So the abstract paragraph here is an electrical particle generator comprising of non-magnetic pipe in a closed loop having a substantial amount of magnetized particles encapsulating inside it. The magnetic accelerator assembly is positioned on the pipe, which has an inductive primary winding and a low voltage input to the winding. A secondary winding is positioned on the pipe opposite to the primary winding. Upon voltage being applied to the primary winding, the magnetized particles are passed through the magnetic accelerator assembly with the increased velocity. These accelerated particles passing through the pipe induce an electrical voltage current potential as they pass through the secondary winding. The increased secondary voltage is utilized in an amplifier arrangement. Prior to art teaching, expound the fundamental principles that a magnetic field passing through inductive winding will generate a voltage current or enhance the voltage across it if the winding is secondary, if the winding is a secondary winding. It is also taught by the prior art that a magnetic element in a primary inductive field will be attracted at one end of the coil and repelled at the other. This is a moving magnetic element and will be accelerated in motion by the attraction and repulsion of a magnetic field of the primary inductive winding. So we're going to get into the summary of the invention, but right here you can see a basic diagram. This looks like the flow here, and then you have I think this is the primary and then the secondary on the right, but I could be mistaken on that. The present invention utilizes the basic principle of the particle accelerator and the principle of inducing a voltage in a secondary winding by passing a magnetic element through it. The structure comprises a primary voltage inductive winding having a magnetic core plus a low voltage input. There is a secondary winding with a greater number of turns than the turns of the primary winding, plus an output for using the voltage induced in that winding. So more number of turns. Like I said, or like I originally thought, this is the secondary on the right, and on the left is the primary. Due to their magnetic polarization charges, the particles will sustain some motion as the particles approach the accelerator assembly, which is the primary coil, and the magnetic field generated by the coil attracts the particles and accelerates them through the coil. As each particle passes through the coil, the repulsion end of the coil boosts the particle on its way. This causes each particle to exit from the coil with an increased velocity. So it's basically like shooting them out.
Yeah, have you ever seen Plasma's channel when he does that?
No. What? Whose channel?
Plasma channel?
Plasma channel? No, I haven't checked that out yet.
He's taking magnets, and what he's doing is he's taking the flow of water and he's allowing it to spin in a magnetic field, creating propulsion from it.
Oh, wow. I know...
So it's the same thing here. You're in a magnetic field. It's wrapping around it. You have a direction based on which way the wire's wound, and you're allowing the particles in the water to magnetize in order to get the flow.
That's cool. I know there was
You just saw the oxygen magnetize. I mean, why not?
Right? Yeah, and plasma, we know that plasma can be affected by magnetic fields due to its
there's
ionization.
no plasma in this device. I'm just saying that's the name of the guy's channel. That's just his channel name. He's working with magnetics and water.
The reason why I brought that up is because one of the experiments that I wanted to do for a while was, take one of those toroidal plasma spheres, and have a spinning electromagnetic field around it that makes it into like a toroid shape.
Okay.
I wonder if I can find that. That was a really cool video I seen on YouTube. Toroidal plasma generator, I think it was. Yep, there it is. Plasma reactor.
This is a toroidal plasma generator. It's basically a device that creates this accelerating ring of plasma inside a glass bulb. As you can see, it's very mesmerizing. The ring seems to be dancing and floating in the middle of nothing. Also, because it vibrates, it resonates with the glass and creates this unique musical sound.
So cool.
To be honest, this looks like magic to me. Not only because I have no idea what's going on, but also because plasma is not supposed to do this.
Something interesting that I wanted to try for a while. But this is the basic diagram of Stan Meyers. It's basically a particle accelerator, from what I understand it. Simplified.
You're still talking about the tubes?
Yeah, the Stan Meyer electrical particle generator.
Okay, which page? 205?
204. I'm about to be on 205 in a second, though. I was just going to read the caption at the bottom. It says, Figure 1 is a simplified illustration of the principles of the invention shown partially in cross-sections and partially pictorially.
No, I get it. It's a flow of energy. I don't know if it's particles necessarily, but it's flow of energy.
It's a flow of energy. So you wouldn't necessarily call it a particle accelerator, but it is an accelerator of something.
Yeah, if you say particles as you're if you're saying the oxygen hydrogen concept, then yeah, if that's what you're referring to. But if you're not, in water, there's not anything more than that. I mean, unless there's something in the system that he picks up somewhere else, like fluoride or something like that. But it's a closed loop system, so you're just pushing the water throughout it, and because of the vortex it makes, you're putting energy into the secondary coil.
Interesting. Yeah, it's again a vortex motion for a system that produces. Apparently, I think it said that he didn't specifically say in the patent because the patent office doesn't take kindly to over unity systems, but I'm pretty sure he kind of imply that this is an over unity system. Here's a different angle or a different embodiment shown figure. Is this a different angle or a different? I don't get it. Is this a different device? Because it looks like there's 3 coils here, unless that's.
Yeah, you use just 3 coils, so you have a multiplication effect.
So this is like a different variation.
Yeah, it probably has more of how do I say, a crystal look than it does the way you see it. So everything would be an equal. So as you see it coming out the side, imagine it 3D popping up when in the section you see it at, and everything has to be equal distance, equal. You know what I mean, so that it flows correctly.
So this is interesting. If we go down to 206 at the top of 206, there's like this toroidal shaped coil. And I know that Stan Meyer had one of the most valuable things that he had wasn't the water splitter car. It was this toroidal shaped power generator. I'm wondering if this is it. I know. Have you ever seen the documentary by Stephen Greer called The Lost Century?
No.
I might stream it on Twitch again at some point this weekend. It's great, and if I do, I'll let you know. It's on Amazon, but I paid for it, so I might stream it on Twitch. So it basically goes into extensive detail on the last 100 years of suppressed free energy devices, and this is one of the things they talked about is this toroidal shaped power generator that Stan Meyer had. Yeah,
well,
it's
anytime you want to get into something like that, you have to have a multiplier. And just understand that if you don't have one of those in your system, then you're pretty much done for. It won't produce free energy.
Right. Here we see the same diagram that I forget his name, Gus, on RWG research. That's what he was showing us earlier.
Yep.
Yeah, so this is I might have accidentally copied. No, that's a different page. So I wanted to go down to page 214. And I wanted to talk about this it's an ionization chamber, it looks like, because it says highly energized gas is coming out of it. Modified argon gas is going in. Highly energized gas is coming out. And it's using light from LEDs, I'm assuming, to ionize that gas. It says, in Stan Meyer's design, he uses 6 columns of 16 LEDs, which each column of LEDs spaced out evenly around the outer tube. So, to boost the magnetic particle generator to greater power levels, a gas processor is placed in the loop of tubing. Yeah, so he calls it a gas processor, but it's basically an ionization chamber. And it boosts the magnetic particle generator, I guess. Huh. Output coils, accelerator coil. Oh, that's cool. That's all I have for the presentation today. If you want to talk about anything else, Nathan, let me know. I do have suggested content down here. If you want me to add anything from your channel, I can do that now as well.
I sent you another video of TT.
Mm-hmm.
Let's see if you have it. Put that up.
Yeah, give me one
It has
second.
to do with the cold energy.
Let's see. You sent it to my Gmail? I don't see anything.
Yes, I did.
Can you send it again?
I think it's actually on the list here in the stream. So when we're writing back and forth earlier.
Oh,
it's right there. It'll
at the
say
top.
anti-gravity and have 3 little spaceships.
Hey, what's up, Lighten for Truth? How you guys doing? Mike says, to me, most of these devices look like EMF simulators or EMF channelers. Yeah, it's interesting. And you said it says UFO.
Okay, try the link I just sent you. I sent it to you in the chat here on the Discord.
Oh, here we go. Okay, yeah, let me pull that up. Copy video.
I just want you real quick while you pull it up. Look at the light bulb that he uses. And he's using his body to turn this thing on.
Oh, does he have any input power, or is it just his body?
No, he does. It's just this is the cold side of his circuit.
I know. The only reason I'm asking is because I know Daniel Nunes specifically said that one of the experiments that he did was you put a tiny, tiny, tiny bit of energy going into the coil, and you just touch one of the series leads, and just your body energy will amplify the voltage and current. Oh, this is the Graviflyer. Nice. And real quick, who is this?
TT. I won't try to say his last name. I'll mispronounce it.
But he's been working on the Graviflyer too, I assume.
Yeah, he's on the Facebook group, and we all communicate with him on the YouTube as well. But he posts a lot of good content on UFO stuff. And he was showing us a voltage doubler circuit. But when he shows it, he's using this. You know what I mean? So he's using cold energy. I don't know, if he just didn't want to say it or if he didn't think we'd understand it right, but he's saying the same thing. It's like the effect with the Tesla coil when you touch the little frame the light bulb's on. When Lexi does it, it shuts off the light. Well, this is the opposite effect where it turns on the light.
Oh shoot, I don't have this on. Hold on. Let me oh, there we go. Sorry, I had that not up on the stream. So you said this basically acts as a kind of like wireless energy transmission? Or does he actually have to touch that to the plate?
Like I said, it's cold light, so he has to touch it in order to create the correct capacitance for the light to work.
But
his body is part of the circuit. It's what pulls it in.
Oh, so his body is completing the circuit?
Yeah. It's like he's pulling in the load with it. You see the light bulb turn it on?
So it's like, it's basically, since it's cold electricity, I'm assuming it's not going to be hot and burn him.
Nope.
That's so cool.
So
oh, I see. Yeah, he took his hand and he touched the, yeah. Oh, wow.
Interesting, huh?
Yeah, that is very interesting. It's another another device that utilizes cold electricity. I wonder if that's just a byproduct of utilizing energy in this way.
Yeah, so let me tell you something about the Graviflyer. When you have the Tesla coil connected to it, but it's not directly connected, it's just down the throat of the coil, right? You just have a wire down the throat, doesn't do anything else, doesn't connect to anything else, just hangs out there, goes through the Graviflyer. Now, you can light this thing up with a ton of voltage. The actual Graviflyer is cold. It's 74 degrees, and it'll burn your hand.
So I was looking on Reddit, and there was a thread. Unfortunately, I think it was closed. I couldn't respond to it. There was a lot of, unfortunately, a lot of skeptical people. But it's just funny because I seen this video. It's very impressive. Where this thing is flying high in the air, and it's obviously like kind of. It's almost like it's stuck to a node in space-time, kind of how like I don't know if you've ever seen like acoustic levitation, how you have two sound waves interacting with each other, creating an antinode where, gravity is just kind of like null for light objects. And they kind of like just snap into place, like and there's a certain area or threshold around that node or antinode that, you know, you can just kind of move it a little bit and it'll just snap back into the center. That almost looks like what this is.
Yeah.
Like it doesn't look like it's being held up, obviously, by like a couple of strings.
It's in a bubble.
Yeah, it looks like a magnetic field effect. Like at least the effect does.
I'm telling you right now, it's in a bubble. It's a field. So if you take your Tesla coil, right, and you connect it to the center plate, and then your high voltage is on the inside, so top and bottom plate on this thing, you can contain that high voltage. Yet if you change it and you put the high voltage to the center and you take your Tesla coil, loop it through the Tesla coil and down to the bottom onto the two plates, right? Now I can take that rotation and I can force out that high voltage field. So when I do that, I can tell it's working. I'll be able to shut my computer off in seconds because of the EM field coming off of it. But I can control the distance of that field. I can quite clearly tell you he's in a bubble.
I want to pull up a couple of videos real quick of Fractal Woman explaining some of Ken Wheeler's secrets of magnetism, because he goes into a couple of ideas regarding producing counter space, and that may be what we're seeing in these anti-gravitic devices. The production of counter space, which is kind of like anti-gravity. You know, he describes gravity as basically, it's not what we think. It's a pressure differential in the ether between two bodies or more. So if we think about it that way, and if I pull up these videos real quick, we might be able to get a different picture on what's going on here. But this is very, very cool stuff. Crypto is here. Hey, Crypto. What's going on, dude? Yes, Free Energy Friday. Yes, I'm down for Free Energy Friday. What about you, Nathan?
Yep, we're good to go.
All right. We still got Nathan on. Why can't we see? Oh, give me 1 second. Where is he? Yep. There he is. Sorry about that. I'm a newbie host. I'm not a veteran like Crypto. He's very good at hosting his Free Energy Fridays podcast, and I appreciate everything that he's done, allowing us to come on and share some of our projects.
Absolutely agree.
Yeah, it's very cool of you, Crypto. Let's see. I'm going to pull up some... Oh, wrong. I'm going to pull up some Fractal Woman's videos, just a couple of them. She has a really cool playlist. I mean, a lot of her work is honestly very, very cool. But there is this videos on magnetism, understanding Ken Wheeler's secrets of magnetism playlist. So we're gonna watch the one on space and counter space right here, and this is very cool.
In those series, I'm going to try to explain.
This is the only video that she uses AI voice, and I do apologize. It's not pleasant to the ear, but it's a very cool video. So,
Explain Ken Wheeler's missing secrets of magnetism. I have been studying Wheeler's work for around 2 years now, and I have come to understand it on my own terms. There are many out there that don't like Ken or his approach to teaching. He has lots of videos out there that aren't in particular order, so you have to sift through a lot of material to get to the good stuff. His book, Uncovering the Missing Secrets of Magnetism, suffers from the same problem. I prefer his videos. Yes, he gets angry sometimes, but anger is his gimmick. It is his thing. This is why he calls himself the angry photographer. Interestingly, he seems to have a lot of followers, and so his gimmick must be working. My intent here is to connect Ken Wheeler's ideas with some of my own ideas about the fractal nature of the universe. What do fractals have to do with magnets? Well, the most important property of fractals is the property of self-similarity. In mathematics, self-similar objects are objects that are approximately the same or similar at many different scales. In other words, the whole has the same shape as one or more of the parts. Many objects in nature seem to have this property. Here are just a few examples of objects in nature that exhibit the property of self-similarity. Notice how the object on the right seems to create a phi spiral. It is found that phi and fractals and nature are intimately related, which is why you see so many phi spirals in fractals and in nature. Magnets are the ultimate, real-life, example of self-similarity. For example, when you break a magnet exactly in half, between the North and South Pole, you don't get a North Pole and a South Pole. You get two new magnets, each with a North and a South Pole. In other words, you get two magnets that are self-similar to the original magnet. When you divide the new, smaller, magnets in half, you get more magnets that are self.
I just want to pause this real quick and emphasize, this is the part about magnets that really blew my mind when I first started studying them. The fact that they always split in half to north and south is just mind-blowing. And to me, that is a signifier, a red flag, that we are missing a vital piece of information regarding their mechanisms.
Similar to the original magnet. You see, magnets and fractals are intimately related due to the principle of self-similarity. This is why I became so interested in magnets and the teachings of Ken Wheeler. Ken understands and appreciates the relationship between fractals and magnets. The mathematical fractal that I am most interested in, and have been studying since 1985, is called the Mandelbrot set. This mathematical fractal also has the property of self-similarity in that, when you zoom into smaller regions of the Mandelbrot set, you find similar little mini-brots that look exactly like the original object. So where do we start with Ken Wheeler's missing secrets of magnetism? Well, it all starts with the concepts of space and counter space. According to Ken Wheeler, the universe consists of two domains. One domain is referred to as space, and the other is referred to as counter space. In this manner, we live in a binary universe. As a computer scientist, I like to imagine that the universe is a computer of some sort. In computer science, 0 and 1 form the basis for the binary system. 0, on its own, is not very interesting. 1, on its own, is also not very interesting. It's only when we combine 0 and 1 that something interesting happens. By combining 0 and 1, we are able to encode the vast amount of information stored on our computers. Space and counter space are like the binary system. What is space? We all have a pretty good idea what space is. We have personal experience with space. It doesn't take a rocket scientist to understand what space is. Space manifests as distance between things. But what about counter space? The concept of counter space, on the other hand, is not very well understood. It is not taught in mainstream physics. It is not part of the curriculum. Counter space, I believe, is a missing secret of magnetism. Counter space, I believe, is a missing secret of gravity. Counter space, I believe, is a missing secret of cosmology and quantum mechanics. And counter space, I believe, is a missing secret of biology and life as we know it. Without counter space, none of these things could exist. Without counter space, there would be no 0 in the universal binary system. But what are the properties of counter space? What distinguishes counter space from space? To explain this, we need to understand a principle which I refer to as the principle of incommensurability. Ken Wheeler refers to it as field incommensurability. As I previously said, there are only two domains in the universe: space and counter space. The domains of space and counter space are incommensurate domains. What does this mean? To understand this, let's look at the definition for incommensurate. Incommensurate. Incapable of being compared. Having nothing in common. In other words, what one is, the other one isn't. So, whatever space is, counter space isn't. Whatever properties space has, counter space is not. For example, if space is big, then counter space is small. If space is expanding, then counter space is contracting. If space is Euclidean, then counter space is non-Euclidean. If space is phenomenon, then counter space is noumenon. Noumenon? What is this? Inaccessible to experience. Exists without sense or perception. Unknowable through human sensation. So if counter space is inaccessible through human perception or experience, then, why bother with it? What new physics, does this bring? This is a very good question. Counter space is like zero in the binary system. How does one experience zero? Zero is the absence of things. Zero is nothing. How does one experience nothing? If we can't directly experience zero, then why should we bother with it? As I said earlier, without zero, we would not have the binary system. 1 is something, and 0 is nothing.
Real quick, the inventor of the thunderstorm generator, Malcolm Bendel, refers to counter space as the ether, which is DC energy at rest. If you imagine direct current energy flowing through a circuit, and then as we know, energy is not created or destroyed, just transformed from one form to another. This is considered its end result when it transforms back into the ether, which is basically that energy at rest, DC energy at rest. So you can think of counter space as basically a reserve or the ether of energy that's just resting and waiting to be tapped into.
Only through the direct experience of something can we indirectly perceive the notion of nothing. In a similar manner, only through direct experience with space can we indirectly perceive the notion of counter space. 1 would not exist without 0 as a reference. In a similar manner, space would not exist without counter space as a reference. This is, I believe, the missing secret of magnetism, gravity, quantum mechanics, biology, and life as we know it. So what does all this have to do with the fractal nature of the universe? I first came to understand counter space by studying the fractal geometry of the Mandelbrot set. Although I didn't originally know what to call it, thanks to Ken Wheeler, I now recognize the Mandelbrot set as a mathematical description of space and counter space. The black part of this image describes counter space, and the outer grayscale region and beyond describes space. Space, in of itself, is not very interesting. Counter space, in of itself, is also not very interesting. What is interesting is what happens between space and counter space. This is what makes things happen. This is what drives the magnet. This is what causes the sensation we call gravity. The interaction between space and counter space is phenomenon. The experience of life, the universe, and everything knowable is happening between space and counter space. The most important thing that I learned while studying nature and the Mandelbrot set is that the interface between space and counter space is always, and without fail, fractal. In other words, the path between space and counter space is nonlinear in nature. This is directly observable and, as I will demonstrate in future videos, undeniable and irrefutable.
As we know, nothing in the universe travels in a straight line other than the radiant energy that emanates out of the aether. So let's catch up with the chat here. Let's see what people are saying. So Mike C, Mike Does is here, and he says, so weird because I know the drive coil is pushing all the magnets stuck together because I added one at time and physically tested the torque with my hand. You talking about? Yeah, I think he's talking about his coil. So Mike is I call him the Lord of the Ring, because he has this really massive, like really cool coil that basically you can put almost any load on. He said, and it doesn't affect the input power at all, which is very impressive. Okay, let's continue on with the Mandelbrot set.
The Mandelbrot set is a key to understanding the relationship between space and counter space. And it is the key to understanding Ken Wheeler's missing secrets of magnetism.
All right, so that was the first video. I'm going to play another video, but it's not going to be with the AI voice, thank God. As much as I like Fractal Woman, that AI voice was pretty bad. I try to take time and make sure that my videos which use AI voice are pleasing or at least easier on the ear.
Hey, you
Principles
guys
of
know
increments.
that golden fractal thing you see on the YouTube?
Golden
You familiar
fractal?
with that?
No, what is that?
Well, it's not golden, it's copper, but it's triangles and it's fractals inside of it.
Mm-hmm.
And then it has spears, of actual copper, like 3 of them. Any idea what that is? You guys ever seen it?
No. If you can, post a link in the Discord and I'll pull it up. If you have
It's
one.
kind of hard, man, with what's going on. I don't have access to it.
Oh, okay.
Anyway,
No, that's okay.
The guy that runs that was asking me about a power source for it. He was looking for one on our site on the on the Facebook. He was looking to put a Tesla coil to it, and he was basically was looking for the radio frequencies out of it to see if they wouldn't amplify in the fractal geometry of the device he has.
That's interesting, and I wonder, because you know, the phi ratio, I have a feeling plays into resonance regarding at least the Rodin coil, and I'm wondering if it plays into other devices as well that require resonance. I did see, I think it was around the third harmonic range of the phi ratio that I did see the Nunez method, open circuit method, work and get some kind of power. I also, I don't know if I told you guys, but the multimeters, they were reading microvolts or millivolts. I forget which one it is. It's the next step down from voltage. But they were reading, I think it was millivolts, and it was 10 times on the output. Now, I can't trust the multimeter because supposedly the ones that I have aren't accurate beyond, you can't trust them beyond like 3 kilohertz, and I was running it at like almost 21 kilohertz. But it did show like a 10 times voltage output, which was very curious. Yeah, right? I thought that was, so it's something that I think is a little bit more of like, it could be a confirmation that the Nunez method is going to work. I just need the proper equipment. We're going to, I'm going to play this,
Hey, I'm Kayla.
this video on attraction and repulsion and the principle of incommensurability. This has a diagram in here, and she explains it. It's a very cool video. I just want to play it.
So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. And to tell you that that's one of
just real quick, this is Richard Feynman. And he's basically saying, like, yeah, we don't know how magnets attract. We don't know why they do what they do. And, I mean, if you look at Fractal Woman's video that I showed on my 0-point energy generator video, that clip of the cylinder spinning in a pool of water, it clearly relates to fluid dynamics. And, I mean, if you think about it that way, it just, you know, the physics makes sense at that point. And he's sitting here saying, "Oh, we don't know why magnets do what they do," and in my mind, it's because, you know, people like him don't consider the ether.
of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others.
Yeah, I know, right?
If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately. That our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
So I guess this is where I come in. Richard Feynman said that he could not explain magnetism in terms of anything that you and I are familiar with, because he did not understand magnetism in terms of anything that you or I are familiar with. I don't think Richard Feynman understood magnetism at all. He knew what it did. He knew that opposite poles attract and like poles repel, but he had no idea why. If he did, he would have been able to explain it in terms that you and I are familiar with. But I think I understand it, and I think I can explain it in terms that you are familiar with. Let's see if I'm right. Whenever I talk to mainstream physicists about my controversial ideas about the universe, especially when I'm talking about the fractal nature of the universe, I always get the same line. Stand on the shoulders of greats. The thing that annoys me the most about this statement is that they're assuming that I didn't already do that. I do think it's important to stand on the shoulders of greats, as long as I get to decide who is great and who is not great. If I think Ken Wheeler is great, do I get to stand on his shoulders? Here's a picture of the so-called greats from the past. On the left is Albert Einstein. Everyone knows who he is. Behind him is none other than Nikola Tesla. Some people know who he is, but they might not realize how great he really was. Beside Einstein, on the right, is Charles Proteus Steinmetz. Unfortunately, no one really knows who Steinmetz is, even though he is one of the greatest of the greats according to Ken Wheeler. The book that I'm showing here, called Electric Discharges, Waves and Impulses, was written by Charles Proteus Steinmetz in the early 1900s. Ken Wheeler recommended this book, and so I read it. I make it a point of checking out all the books that Ken Wheeler recommends because I think it's important to stand on the shoulders of the people who stand on the shoulders of greats.
Real quick, I'm just going to interrupt, and we have a question from Mike Does to Old Man Builds. There is something about using iron core around wire to prevent signal interruptions to the point where the wires melt. I'm not sure what that's in reference to, but maybe you'll have some kind of context for us.
Iron core or iron wrapping around the magnet?
He said, there is something about using iron core around wire to prevent signal interruption to the point where the wire melts. It's those...
Like heat.
Yeah.
It's like a heat bomb.
He said it's those small half-circle clamps they put around the wall wire. Oh, and Nathan, it's going to be 9 o'clock Eastern Standard Time, so what, you're 3 hours behind us? So it'll probably be like 6 o'clock.
Oh, about normal. Okay.
Yeah.
Yeah, I'm not sure about the clamps on the wall. I understand that they have clamps when they do electrical. And generally, those little clamps are used for the bare wire, so your ground wire. And wrap them, put the little clip on there, lock them. As far as, coil in there, I'm not too sure what he's talking about.
I don't know. Regarding Free Energy Fridays, I think I might try to demo off some more of the Schumann resonance. I remember, I don't know if you were there on the live stream, but when I turned on the Schumann resonance, 7.83, I think it was, the magnetic sphere, the neodymium sphere in the glass container that I had was actually vibrating the glass outside, like way outside of the donut vortex, which was really cool. And I had a really small container, but I got a little bit bigger of a glass, shot glass container. Well, it's not really a shot glass, it's more of a Scotch glass. But well, I want to, maybe tonight I'll see if I can actually get it to start spinning.
You need a vase.
Yeah, you're right.
So, yeah, you know what I mean? Get the shape kind of up like this and get the magnet down the bottom and see if it won't vortex for you based on the spin of the magnet that you're creating with your actual coil. That'd look totally rad.
That is brilliant. No, that's brilliant. You're saying putting the small part of the vase at the vortex?
Yeah, so
yeah.
Basically what would be even cooler if you took two of them. So you seal one and put it upside down and see if you can't get the magnet to stay, up towards the small end. And then do the other and see if you couldn't get them both the vortex inward, to each other. That'd be totally awesome.
Yeah, it's really this neodymium sphere like is really cool to work with. It's just I gotta be careful with it, you know. It's a pretty big one. I'm thinking that I got one that was a little bit too big though to do the levit. You know how you see the videos and some people put the sphere in the center of the coil and it levitates?
Yeah.
I think mine's a little bit too big to do that.
Well, just get a set of neodymium magnets and just get the rectangular shape. And all you have to do is 3D print a device with a bearing. That way it could sit in the top and bottom of the vase, basically both the bottoms, I should say. And then when they sit right directly across from each other like this, then you get them to be able to spin both of them. So you would be creating the vortex up and down just like the Earth would. So
right, you would be mimicking that.
Yeah, what would even be cooler than that is now you take something and put it in between and put a second coil on the bottom and show this thing just like you would the ether, a flow of energy.
Oh, wow. Yeah, that would be cool. No, this is really cool. I'll definitely try that. Also, by the way, I did notice that amazing dreamsicle colored rodent coil you have in the background.
Oh, yeah, hold on. I'll show you. I think you get a good shot of it.
Yep,
So I got
everybody.
the white one ready for you.
Wow,
That's ready to ship, man.
That looks real nice.
In case you wanted it, I'll include these with it. You get an extra one of these, and you got an orange center to go with it, just an extra.
Oh, that's so cool. I really appreciate that, dude. That's gonna be that. So everybody, Nathan was kind enough to print me off a second coil frame, so I can start winding my second coil and have a backup, and test it against the first one. Hopefully, do better. Oh, it looks cool. That's the orange dreamsicle color.
Yeah, make it any color you want, man.
No, it's really cool. I like it. I appreciate that, Nathan. That's gonna help out a lot. And also, I am going to be finishing up your intro video by next week, hopefully. So that's gonna be pretty. Yeah, yeah. I'll do.
You see my picture of me when I was 18 years old? Oh,
yeah. There's a couple of different ideas I had for it, so I'll talk to you about that off stream because I don't want to give away all my content creating secrets. But
no problem. I just thought it was hilarious, man.
Yeah, no, it's gonna be it's gonna turn out really good, and I'll be able to put together that quick stream starting video for you, and eventually down the line I'm gonna put together a proper intro video for your channel. So like if you have recorded videos, you can just put that at the front of your videos,
Well, I'm hoping to get my Graviflyer flying, and you can put that as my intro. That's what I want.
Yeah, have some nice shots of it.
Yeah, I'm not going to cheat it to do it. So.
No, and it'll get there. And when that time comes, that will be one sick intro video. Trust me, we'll get it real nice.
Yeah.
Like I said, every cool. Yeah.
We'll play a little Impossible Dream behind it. If you ever heard the song, that's what we're gonna play.
I can dig it. But yeah, no. Like I said, every cool channel deserves a cool intro video, and I don't mind helping out on that front because I have a little bit of skill on that background. I started out in radio, TV production, so.
Oh, right on.
So it's kind of like a cool hobby of mine. It always has been, and I don't mind helping out other channels. It's always something that I've done, and I think it's what other people should do is network and help each other out, because at the end of the day, we're all in this in the same goal together, is to talk about free energy and get it into the mainstream light, right?
Yeah, absolutely. The more we all understand, the easier it's going to be for everybody.
Exactly. Yeah, and as soon as you get that Graviflyer working, we're going to start drawing up designs to fly us to the moon. I'm going to see if there really is
I want to see Mars. That's my thing, man. I want to see Mars with my own eyes. I want to see the pyramids there.
Yeah, me too.
The face.
Exactly, yeah.
I'm tired of seeing rocks. They tell me that they're one color when they're not. And
they're one color. they're a color this today, and then tomorrow they're a different color, and then they have some BS excuse. So like, oh, it's a filtering, and
they just make something up. They just lying to us, dude. That's it. There's no way of getting around that. You watch these channels and they tell you, oh, you just kind of colorfully put it together. So you have no idea. Is that what you're saying? You just no clue.
That
so
is.
I don't feel bad about making something up now. I just go, well, I wanted a planet that looks like this. That's out there somewhere.
Right, and that's
like them.
That would be one of my number one goals, is to go to the moon and Mars to see if there really are, like, structures and, what's there, that they're not telling us about.
I want to visit that shard on the moon. I don't know if you ever saw it.
Shard on the moon. Yeah, the big column, right? It almost looks like an antenna or a transmitter.
Not necessarily a column. It's like a shard. It's basically like a rock that's suspended, and it looks like it's floating a little bit. And
I don't think I've seen that one.
If you have ever seen the Egyptian hieroglyph, where it shows the UFO on it, if you look a little bit down and to the left, I believe it is, you'll see the shard right there. So, yeah, it's right there on there, and part of the hieroglyph. So they obviously knew about it. It's like, I love hieroglyphs and stuff and putting it together of real things that are going on. If you've ever seen the Black Pyramidium, the cap that goes onto one of the pyramids in Egypt, it's in the museum, Egyptian museum. It's black, right? So on the right side, on the left side, you'll see the eagle thing, and then on the right side, you'll see Oumuamua. I think I'm saying that right. That thing that came through our solar system. It's right there. It's got the telltale sign of it. When you see the thing come together like this, it's right there. And it's totally extraordinary. They knew it was coming. They timed it when it came down. It flew right through where you could see it on the Day of the Dead in Mexico.
That's crazy. We have there was just a video I was watching, I think it was from the History Channel, that showed a couple of UFOs appearing above one of the, I think, Mayan pyramids, and just appeared and then just disappeared like instantly. Is insane. I would like to be on that ride for sure. That's got to be one intense ride.
Yeah, tell me if they showed up at your house, you'd be like, well, I got things to do. Heck no. Forget everything I had to do. I'm going to yell in the house. Gotta go, guys. Out. You know what I mean? I don't know when I'm coming back, and I don't care. I'm just, the old man's out of the building. We are going to the Mars.
Since we've been talking about like anti-gravitics, and I've been doing research into the history of anti-gravitics more, we see like a lot of inventors who apparently have achieved that anti-gravity effect. And now I'm seeing reports of every once in a while you see somebody say hey, I saw a guy with a jetpack just flying around. It looked like a guy with a jetpack just flying around in the air. I'm wondering if some, inventor out there just has like an anti-gravitic jetpack and just flying around random places. And, and that's what we're seeing with these, random videos of people saying, hey, there's a guy flying up there.
What would be really cool is if you ever listen to ODC Carr when he talks about the UFO, right? And he talks about time travel with it. And what would be really awesome is if in the future they didn't understand it yet, and it was the thing that was traveling back to the past and then back to the time in the future, and when it disappeared, it would do the time travel. That would be completely amazing right there. That'd blow my mind.
Yeah, and that would definitely give credence to the title Back to the Future.
Yeah, that'd be awesome.
And a side note here is I am working on a new video that goes into real life flux capacitors. So, the truth is stranger than fiction, I always say. And the science that we were talking about constantly, these fringe theories, is stranger than fiction. And yeah, and I'll be releasing one of my new Divine Science specials, a highly produced video, fun, funny, entertaining, educational. It'll be maybe like 10, 15 minutes, not too long. But I should have that out next week for you guys. Just something fun to watch.
Right on. That'd be cool.
Yeah, and this all is based on Bob Greenyer's research of the thunderstorm generator and how supposedly they found 30,000-year-old carbon-14 aged in the inner sphere, indicating that there's time dilation happening, which is insane. I'm gonna continue on. Yeah, I'm gonna continue on with this video though. This is a really cool video.
Feynman never met Steinmetz.
Remember we were talking earlier about the oxygen and the magnetization?
Mm-hmm.
If you ever taken a quartz crystal and put it near a speaker?
No, I haven't.
Okay. Because there's oxygen in it, you can magnetize the oxygen inside that crystal because of the structure of it. Okay? So there's a slight magnetic there, and if you ever run across the video on it, at least you'll know what it's doing. It's magnetizing that oxygen. So it's kind of a cool thing, you know what I'm saying? So if you can understand how to get to that frequency of that oxygen in there and resonate it, you're going to produce energy that flows outward in a crystal because you can't put it through the crystal. It won't go. You have to produce it on the inside and let the energy come out.
So it's basically
I would do it.
It's basically a way to tap that oxygen that's trapped inside the crystal.
There you go, because everything works on a resonance frequency, and if you can find it, then you can apply it to that, and then it would work.
That's cool. I wonder if we can...
It's just like when you take the quartz vein and you have gold going through it, you resonate the gold, it taps on the quartz 1,000 times a minute, or whatever it is, and the quartz will light up, just like that.
Yeah, I know John Hutchinson had a crystal battery, and he wouldn't disclose some of the materials that he used ground up in this battery, but it utilized crystals and resonance to some degree, I believe. And basically, once you get it going, you just get the constant, however much voltage and current it outputs. It just constantly outputs that, and it won't ever dissipate.
Because it's continuously creating it. There's no, you're not destroying anything when you're doing it. You're just creating movement on a different level.
It's like the crystal acts as a channeling device or a transducer, right?
I don't know that it acts as a transducer. It's just an energy source that we're not tapping.
So it's not transforming the energy, it's just tapping the reserved energy inside of it.
It creates its own energy. It is literally creating the fabric of energy.
Is that something that's unique with crystalline structures?
Yeah. That's what's so cool about them.
That's interesting. Yeah, and then they want us to believe that magnets attract to each other because of the alignment of atoms. Like that makes any sense from one material to another. Like I know like aligning the atoms neatly will produce a crystalline form, but like there's to jump from that to like, this other material is going to attract to it if it's aligned properly. That doesn't make any sense.
Well,
but that's the traditional way of that's the traditional science that we're taught, and
it's
kind of flawed in my opinion.
I think magnets just put a charge on something, and based on the material that the charge is placed in, that's what makes your magnetism in ferromagnetic materials, and that's all it is. It just manipulates the material it's in. So I always tell people, if you want to create a great motor, put cobalt in it. Don't put soft iron. And then as you start running it, supercool it. It'll turn into a superconductor, and it'll make this massively fast motor. So by just changing the material that you're looking at, changes everything.
And I'm assuming cobalt is easier to supercool than other materials?
Yes. Yeah. It has a much lower supercooling temperature, yes.
That's cool. All right. I'm going to continue on with the video. I appreciate all the awesome knowledge there. Always blowing my mind with this, I can't cuss, with this stuff. I always catch myself.
Work. If he did, he would have
Yeah, we're on
understood the
YouTube, can't say
relationship
that.
between gravitation.
Yeah, I try not to. I mean, there's every once in a while I do cuss and it slips, but I try not to because YouTube, I think, counts it against you or something, right?
Yeah. You should just understand that some of my videos, when you hear me voiceover, there's a lot of that going on.
Forces and electrostatic forces of attraction.
I'm actually going to go to the bathroom real quick. I'll be right back.
He would have been able to explain it in terms that you and I are familiar with. The picture you are seeing here was taken from this book. This is a depiction of what...
Oh, Mike asked if we could talk about time travel. Yes, we can get into time travel after this, of course. I love talking about time travel.
Ken Wheeler calls field incommensurability. This is a depiction of the magnetic and dielectric fields generated when charges flow down a pair of parallel wires like in electrical power transmission lines. Remember, we talked about this in a previous video. When charge is moving in the same direction down parallel wires, the wires attract. When charge is moving in opposite directions down the parallel wires, then the wires will repel. In the case of the power transmission lines, the charge is moving in opposite directions along the wires, and so the wires repel. This picture shows the cross-section of the wires, the black dots, and the corresponding fields. This is identical to the field incommensurability found in and around the magnet as seen in the ferrocell. This is what drives the power line, and this is what drives the magnet. In order to understand the true nature of attraction and repulsion, you need to understand this picture. Ken calls this picture the most important picture in the universe, and I have to agree that it is very important. Everything you need to know about attraction and repulsion can be intuited from this picture. On the left is what the field looks like with just one wire. The concentric circular lines surrounding the wire correspond to the magnetic lines of force. The linear radial dashed lines correspond to the dielectric lines of force. First, I would like you to notice that magnetic lines of force never touch the wire, but merely surround it. The dielectric lines of force, however, do touch the wire. Here, the wire can be thought of as a terminal for the dielectric lines of force. This is where the lines of force terminate. This is the field geometry of all objects in the universe when they are not in close proximity to another object. This is what I define as a charge. This is the field geometry of a single charge. When charge is in motion, the magnetic lines of force expand, causing an increase in the pressure between the magnetic lines of force. When charge is in motion, the dielectric lines of force contract, causing an increase in tension along the dielectric lines of force. This single-wired field modality can be easily seen in this image of a magnet and iron filings on the right. In this picture, the North Pole is facing up and the South Pole is facing down. As you can see, when the magnet is in this orientation, the iron filings self-organize into the exact pattern as the single charge field modality as depicted on the left. Here you can clearly see both the circular magnetic lines of pressure and the radial dielectric lines of tension. Notice that I didn't call them lines of force. The term lines of force is ambiguous, since it can be applied to both the magnetic and dielectric fields. The term flux lines is also ambiguous, since it can be applied to both the dielectric and the magnetic fields. Given the many ambiguities in the language of mainstream physics, I will now define my terms as follows. The term charge refers to the field geometry in this image. Single charges in motion all have this field geometry. Since the dielectric field stores potential energy, the dielectric component of the field will now be called electropotential. So the dielectric field will now be called the electropotential field. And the dielectric lines of force, or flux, will now be called lines of tension. In a similar manner, since the magnetic field stores kinetic energy, the magnetic component of the field will now be called magnetokinetic. So the magnetic field will now be called the magnetokinetic field. And the magnetic lines of force, or flux, will now be called lines of pressure. This disambiguates the language and makes it much easier to visualize. No one is going to confuse a line of pressure with a line of tension. With tension lines, the force is along the flux lines. This is the longitudinal component of the field. With pressure lines, the force is orthogonal to the flux lines. This forms the transverse component of the field. As you can see, the magnetokinetic lines of pressure are orthogonal to, at right angles to, the electropotential lines of tension. Where these field lines cross, that is what humankind calls electricity. Where these field lines cross, this is what I call the medium for the propagation of light. The image on the right is what the field looks like with two wires. Here, the magnetic field lines are no longer concentric. Instead, they are shifted laterally, causing a pressure gradient between the particles. Ken Wheeler says that all repulsion is magnetic lines of fields under pressure. Also notice that the dielectric fields are no longer radial. Instead, the field lines form arcs that are connected to the two wires. The dielectric field lines terminate on the wires. In other words, dielectric lines of force form a connecting field. In short, it can be said that magnetism is that which separates things, and dielectricity is that which connects things. Increasing the tension pulls things together. Increasing the pressure pushes things apart. Since it can be said that dielectric field stores potential energy and the magnetic field stores kinetic energy, I'm going to use the terms electropotential when I'm talking about the dielectric component of the field, and magnetokinetic when I'm talking about the magnetic component of the field. It is well known that total energy equals potential energy plus kinetic energy. It is also well known that all oscillating phenomenon, including waves, including pendulums, including LC circuits, all slosh back and forth between potential and kinetic energy. This includes the phenomenon we call electromagnetism, otherwise known as light. In terms of the principle of incommensurability, the terms potential and kinetic are incommensurate principles. Potential energy is not kinetic energy, and kinetic energy is not potential energy. So, electropotential fields and magnetokinetic fields are incommensurate. They are nothing like each other. For example, the magnetokinetic field terminates on self. It terminates on itself. Electropotential field terminates on other. Electropotential field is the cause of attraction. Magnetokinetic field is the cause of repulsion. Therefore, attraction and repulsion are also incommensurate principles. Here on the left, you see an image of iron filings under the influence of a magnet. The image on the right can now be identified as the electropotential magnetokinetic field, formerly known as the electric field. For simplicity, I call it the ohm field for reasons I will explain in another video. Iron filings, under the influence of the ohm field, as made manifest by the magnet, produces the pattern seen on the left. Clearly, what we are seeing here is the electropotential lines of tension and not the magnetokinetic lines of pressure. It appears that mainstream physics does not distinguish between electropotential and magnetokinetic lines of force. But pressure and tension are incommensurate principles and must be treated separately. The ohm field consists of two interlaced incommensurate fields. As the iron filings experiment is better suited for showing the electropotential lines of tension, the ferrocell experiment is much better suited for showing the magnetokinetic lines of pressure. Both experiments are needed to see the whole field. Now, Richard Feynman, when someone asks the question...
My headset died, so I had to give it some time to charge as well. It doesn't have a good battery life.
Gotcha.
So what do you think so far about these different ideas of magnetism?
You know, like I said earlier, I have my own view on it. It's based on the energy you put into it. But I think it has to go back to the atomic level and how you actually create that energy. And I think it has to build out from there. I understand the fractals, but you're not going to get them without the flow from the atom.
Right. So you have to have a strong understanding of what the quantum electrodynamics of the system.
Yeah.
Something like that.
You really do.
Yeah. Okay. I was hoping that some of this content might resonate with some of you guys. So with that, I'm going to move on to gravity, which was requested by, I think Mike requested it. Let me see.
Yeah, we're having an interesting discussion right now in the comments.
Yeah, let's get caught up on the chat here and see if we can't segue into anti-gravity. I think that's what he wanted to talk about. Oh no, he wanted to talk about time travel. Sorry, he wanted to talk about
Ralph Ring. So
Ralph Ring, okay.
Yeah, with Otis C. Carr, and Ralph Ring was one of the people working on the craft with him.
Mm-hmm.
And then Ralph gave a lot of interviews about how it was powered and stuff like that.
Oh, cool. Could Mike or someone, could you post a link to one of his videos and we'll check out some of his work? In the meantime, I'm going to see.
So check it out real quick. Joe made a comment about the coil.
How do you spell his name?
Yeah, he's talking about the rotation of the coil, and we're talking about solid state and how it flows and the energy flow. So imagine this. You get the round ring, right? And then outside of that, you put what looks like little waves, right? And each one you put like that. And it shows the flow in the motor, okay? Now you can actually make a motor like this and have it run based on the flow of energy instead of rotation. And they make a pancake motor just like that.
I see. Oh, wow. So I'm trying to pull up some information on Ralph Ring.
Mike just left a comment in the thing.
Oh, he did? Let's see.
Yeah.
Oh, here we go.
I know one lady who said that She was
you gotta live
asked
that
to
flow
use
of
her
energy.
mind to help.
Yeah, Gerald, I'm totally looking forward to what you're doing, man. By the way, so absolutely awesome. I think I figured out a lot of little tricks, but I know I don't have them all. So
Could you
that coil is going to be really awesome.
For my sake and the audience that might be unaware, could you give me a rundown of what he's working on?
Basically, Gerald's got this coil, right? And he's putting in a certain amount of watts, and he's getting a higher wattage outward, okay, from it. And not only that, he's lighting up this light with LEDs on it, and it's super bright, right? But the actual amount that he puts in wouldn't even give you like a quarter of the amount of power that you would need. So he set this thing at the right frequency, okay? And this is just my opinion of it. He sets it at the right frequency, gets it up high, gets it to pulse right, it goes into the coil. It goes in and it's hitting these capacitors, right? But he's hitting them at the right geometry angle in order to get them to pulse the secondary coil in there. Therefore, he's able to get more energy. Now, I'm not too sure if he's got a third coil in there, but it looks like he's taken all of the things that you would normally like take out of your circuit, and he's adding all of those things in, those little special events that's actually giving you energy spikes, right? And you're able to put them back into this thing and amplify them because you look for them. That's what was amazing. So like I said, I think he's got way more in it than what I said, but I can't wait to see it.
That's very interesting. Yeah, any kind of over unity system, I'm down to see. I'm wondering.
Just check it out. He talks tonight about the geometry. If he brings up tonight or tomorrow, pay attention.
I'm trying to remember. I think he was demoing it when we went on live Free Energy Fridays once before.
Yeah, I don't think you understand. I binged his channel, okay? I'll probably tell you this. I went through every video, okay? Just to wrap my head around what he did.
Post his channel.
He's got it on there right now on your thing. You can pull it up.
Where is it?
Hey, Gerald, leave him a link if you can. Anyway, I binge watched his channel because I wanted to see what he was thinking in his other experiments that led him to this one. Okay? The fact that you could take and recharge batteries out of this thing, and multiple ones at a time. And it could just be a trickle charge into them. But if you want to create over unity, you need a load division. So you need somewhere in there either a capacitor or battery in order to take the load so that the other part of your coil can bring in the energy. So you prove this by by charging multiple batteries. You're able to drive from one load to the next, one battery to the next, and you actually will have everything charged except for the one you're using. That's an amazing over unity property. Most people, as soon as they see a battery, they're like, hey, I'm out of the room, but they don't know what the heck they're doing.
Yeah, that's very, very good practical application. So I think I might be getting confused. Is Mike Does Gerald? Is that the same person?
No.
No, because I'm trying to find him in the chat.
WPGENLIGHT.
Oh, Lighten for Truth.
Truth 2.
There we go. Lighten for Truth.
There you go. Yeah, it's like, okay, imagine this. Take Anchor Watt. You ever seen the picture of it?
Yes, I love Anchor Watt. It's one of my favorites.
So check this out. If I told you I could take a Tesla coil that's a driving coil, so the main coil, I'll put it at the center. I took the 4 towers that are surrounding it, and I made those Tesla coils, but they're receiving coils. I take the space in between them, and I make a water and salt battery. I could take that and run that again another further length out. Because those coils are receiving and not transmitting, they constantly charge the batteries in between them. Now, I can run load off of that all day long and still have the main coil charging everything. You can create over unity in that way easily.
Hold on. So you said Gerald showed this off on live stream once. I think I may be getting Gerald confused with Mike Does. I thought Mike Does was the Lord of the Ring. I think I may be getting him confused with Gerald, who had this
Gerald
sacred...
has the big coil and a lot of multimeters to it.
Yeah, it's like a big circular coil that's wound in a he said it was sacred geometry.
But it doesn't say that on there. You have to know that.
Right, but I think that's what he mentioned. If I'm not mistaken, I may be getting Mike Does confused with Gerald in terms of who's the actual Lord of the Ring, and I apologize. I'm kind of a nitwit like that way. Anyways, yeah, that's cool as heck. I thought that was a really cool coil, and honestly, I think he's got some cool stuff to teach me. If he's willing to teach me anything, come on to live stream at some point. I know I want to continue with this Ralph Ring, some of what he has to say, though, on the OTC X1 spacecraft.
Control one, but Ralph Ring is the only person I know who has co-piloted a flying saucer that we made. He has lived in Las Vegas on and off for about 40 years. Please welcome Ralph Ring.
Thank you.
You're welcome.
Good morning, everybody. Can everybody hear me? I can't see you, but I know you're out there. And I want to be able to thank you all for coming, and I want to thank the source for all of us being here together. I'm going to talk to you today about a little bit about me and a lot about Nikola Tesla, Otis T. Carr, and the OTC X1 spacecraft, which I had the privilege and honor of having a great deal of activity with. I guess it started for me when I was a kid. We lived in the woods in Northern California, a place called Paradise. It's just up above Chico, California. And we used to walk to school 7 miles round trip every day, my sister and I. And during that time, I learned a lot about natural law, about how things are, how things work. My strongest experience was with an anthill that we ran into. I wanted to pester it with a stick to see what they do. And before I got done, half of my body was stinging all the way home. I realized you don't mess with Mother Nature unless you know what you're doing. And from then on, when we passed the anthill, I had a great deal of respect for them and their home and everything else. And I knew that that would have to carry on through my life and everything that I did. So I learned a lot. I went on later to school. I was in science. I really liked science, but I liked the natural science. And I remember one time I was on the second floor of the high school in Santa Cruz, California, where we were living at the time. And the science teacher, it was physics, and he was saying that aerodynamically a bumblebee can't fly. That was the topic. And I was listening to him, and at that moment on the second floor of the classroom, I was looking out the window, and there was a big black bumblebee with yellow stripes around staring at me in the window. And I said, which one of you guys? I couldn't figure it out. So I made a choice and decided to go learn more from nature than I was learning in school. And so I kind of graduated back out into the woods, and I met a good friend of mine. In fact, his brother and I worked with Otis Carr in the Apple Valley when we developed the spaceships. His name was Arthur Aho, and he wrote a book. I don't know if it's still in print or not, but it was called Tomorrow's Energy Need Not Be Fuel. Tomorrow's Energy Need Not Be Fuel. And one of the chapters in there was on bumblebees. And so I became acquainted with him, and we got into the mechanics of what bumblebees do, and it was quite simple. Aerodynamically speaking, and giving credit to my science teacher, they don't fly, but they do levitate. And how they levitate is quite simple. They have
bees are real,
hollow
for lack of a
cavity,
better word, fat,
just
right?
a little shaft, and they start beating their wings, and they start changing their frequency of their environment. And when they get to the
Bees are
frequency
attracted to
of
resonance.
their surroundings,
Beekeepers use it all the time.
and as an
That's the
analogy, I'll
important
use the
thing here.
Earth's frequency of 8.5 cycles per second. When they reach that frequency and resonate in that cavity, that beating of the wings, they reach what's called 0 point.
Wow. No, see, that makes a lot of sense. Like the Beatles, because I was just thinking, you know, like the body mass of a bee, it's pretty big to be, you know, flying around compared to its wing size, right?
Yeah, it's bigger than it should be.
Oh, this makes a lot of sense. This is cool.
Beetles have a resonance chamber on them along with the frequency of the wings, so it's a little different.
Right, is that what the shielding is? That case?
The shell?
Yeah, the shell.
Yeah, and they have those little, I call them little hairs, pick up all the frequencies.
Right. Yeah, the little tiny hairs on the surface. I remember watching the video. I can't remember the scientist's name. He's like a Russian gentleman who was doing experiments with the beetles.
Karpennikov.
Yeah, Karpennikov.
Yeah.
Okay, I'm going to continue the video. This is cool.
No longer captivated by the surrounding gravity. They are then capable of going wherever they want to go. They have their own little bubble of gravity around them that they can do anything with. So that intrigued me, and of course fascinated me quite a bit. And then I later learned about hummingbirds, and hummingbirds do similarly the same thing, and there's some lizards that do the same thing. So I had always been interested in magnetics, and I went on and went into the military. I went into the, in 48, I went into the Army in Fort Ord, California. They eventually shipped us out to Guam. I kept putting in for engineering school, and they said, no, infantry, and they kept kicking me back to the infantry. So while we were on Guam, Korea broke out, and we were in the middle of the night, rushed out, and we made the Wonchon landing in North Korea. And that was quite an experience of what we can do to each other, the harm, the killing, the maiming. It was an incredible experience for me, and I became an objector to killing, and I admit I fired my guns, but I think they all went in the air because I didn't want to shoot anybody, and it bothered me. Well, anyway, make a long story short, I got out of the service, and I was in the 3rd Division, 7th Regimental Combat Team, which their whole function was heavy weapons. They had machine guns and mortars, 4.2 mortars, and big heavy artillery, 1.5 heavy artillery. So when I got out of the service, I was wondering, what am I going to do? I couldn't go to engineering school like I wanted to, and I didn't have the money then to go back. But while I was on Guam, I had learned to, in my leisure time, to go down to the beaches, and I started snorkeling and skin diving. And it was wonderful. It was a whole new world that opened up to me. I realized there was a lot There was everything I didn't know about life, and I wanted to learn more. And it was all natural, so I was in my element. So when I got out, I started a skin diving business, scuba diving business in San Francisco, California. And at that time, there was a large company, Podesta Divers, that did deep sea diving work, but they couldn't handle the little stuff. So I merged with them a little while, and then I went off on my own, and I got into research and development. I got into recovery, repair. I worked for insurance companies on different claims underwater that they need to have proof of. And then I went to Northern California on mining expeditions. We used suction dredges to dredge the bottom of creeks for gold. And we did pretty good. We had a lot of fun doing that. Well, anyway, I'd been wounded in Korea. I got wounded 4 times, and I had frostbite. Both my feet were frozen, my hands. And that was kind of I never really got over that. I still had limps and bad circulation in my feet well, I still do. But I had family down in Newport Beach, California, which is Southern California. That's down near San Diego. And so I progressively moved down the coast and started diving off the coast there for all kinds of things, even abalone diving. I did a lot of diving. I met my first wife down there, and we got married and had children. And I continued to dive for a while. And the type of diving I was doing interested some people one day on an adjacent boat, and they came over and asked me what I was interested in diving, and I told them that I was a research diver, that I like to learn and develop techniques. Well, the boat that pulled up alongside of me was from U.S. Divers Corporation, and that was Jacques Cousteau's company that developed the Aqualung. And they were located at that time in Santa Ana, California, which was adjacent to, well, just close to Newport Beach. And my family and I lived in Costa Mesa, which was close to Santa Ana. So they asked me if I'd be interested in joining them in the research and development department. And I was very excited about that. I thought that would be a wonderful opportunity. So I got in there, and then my curiosity and creative part of me started creating ideas that we could use. And eventually, I had the honor of being offered a position of head diver on the Calypso that was going to be on the West Coast. He already had one on the East Coast and was traveling around the Caribbean and so forth. So I thought that was I'd just do that for the rest of my life. That was going to be fun. Well, in my work, my particular job at that time was the wraparound mask. They had a mask that had distortions, and you couldn't quite see out of the corners of them. And I was diving off of Catalina Island. We'd go out for 2 and 3 or 4 or 5 days at a time, checking out different things, and mine was a mask. And I had to check it for leaks and pressure and so forth. Well, my wife got kind of nervous because I've had some close calls. I went down too deep and ran out of air, and I had to come back up. And there was a few things with the elements that I ran into that kind of scared her, and we stayed out a little too long to suit her and my kids. So she said, no, we need you more domesticated. We need you the kids need you. You've got a family here. And she had a valid point, but I didn't know what to say. That's all I'd ever learned. Well, she picked up a newspaper one day, and it was an advertisement. It was an ad for...
So we have a comment to Nathan. Give me 1 second. I'll pull it up. My apologies. I'm letting my headphones charge a little bit. So, Lighten for Truth says, "Hey Nathan, one of the reasons why I'm into all this is a story I will have to tell you sometime. Crazy, LOL. I should not be alive." So, that is a
we'll have
comment
to figure out what that
from
story is
Gerald,
at some
I
point.
believe.
Yeah, Gerald.
A research and development technician, a lab tech, at a place called Advanced Kinetics, and that was located in Costa Mesa, California. And she said, they're looking for a lab tech. And I told her, I don't have any I don't have any experience. I don't have those credentials. And she said, well, you've got all the credentials in the world about your tinkering. You stay up every night, all night long, tinkering with things, and your interest and findings in natural law, I think you should go talk to him. So, make a long story short, I did. I went over, and it was lunchtime when I got there, and there was nobody around. The receptionist wasn't even there, and I was walking down the hall, and I went by the director's office. His name was Dr. Weinhoff, and he happened to be in his office, and he said, well, what are you doing? And I told him, and he said, come in, sit down, and what's your qualifications? And I said, you got me, goodbye. And he said, no, sit down. And I said, well, I love natural law. I think if we all could live by natural law, there would never be any problems, because you know what to expect, you know what to do, and you're always guided in the right direction. And I told him about the bumblebee and the lizards and the snakes, everything that I'd done to learn about it, and that my primary interest in life was magnetics. I was fascinated with magnetism. Well, he said, just 2 weeks ago, we had one of our technicians leave, or he was an engineer. He was working on a project that we have that happens to deal with magnetism. And would you be interested? And I said, well, sure, but I haven't filled out an application. He said, no, are you interested? And I said, yeah. He said, go to work tomorrow morning. So I went home and told my wife, and she was elated. She was, money in the bank again. So, and they were paying pretty good money, but I was flabbergasted. I couldn't believe that he hired me on just my honest truth. That's what got me in there. Well, the experiment that I was working on was, and this was in 1955, I think, or around in the mid-50s.
So, am I playing the wrong video? Somebody sent me this video to play, and it looks like you sent me Gerald's vortex coil video. That seems to be something that I'd want to check out. But I think Gerald, somebody posted this in the chat.
Yeah, it was me.
I
sent it to you on the what is it called?
Did
Discord?
you guys want me to continue playing this, or did you want me to play some of Gerald's coil videos?
I think we should play Gerald's coil. I've heard Ralph ring a million times.
Okay, so let's move on to some of Gerald's coil videos. This looks like a long video anyways, and to be honest, some people are very slow at getting to the point.
Now it's going to take a while before he gets there.
Yeah, so we could be sitting here for a good minute. Copy the link. So let's put this one in the... Oh, no, that's not the right...
Oh, man. we go.
Look what they're doing with AI experts.
Unbelievable.
So that's how they're growing so fast. They're hiring freelancers.
Nope. Okay, let's shut that off for a second. All right, so
we
this
have
is
an
Gerald's vortex
absolutely
coil.
amazing coil to look at today. I don't know everything about it,
yeah,
but
baby.
I hope to soon.
Oh
This is
yeah,
Gerald's
baby.
coil. He will
You
be
hear a lot
on
about
Apex
this tonight and tomorrow.
You said what?
You hear a lot about this tonight and tomorrow.
Oh, I can't wait. I can't wait. This is, I don't know. Like, I've been really getting into coils. Like, this is really cool to me.
July 6th. He will explain exactly how this coil works. It's like a Russian nesting doll. Every time you peel back one layer, another one appears.
Huh.
Let's get into some of the videos that Gerald does, and I'll give you my opinions about it, and then we'll listen to Gerald himself
Lord
when he
of the
explained
Ring.
it on Free Energy Friday. One of the biggest questions that's going to come up in this, is it unity? Is it over unity? Is it a different way to understand exactly how to build a coil? We can see he has a bifilar coil. He also has iron cores around the exterior of it, and he puts iron cores sometimes on the interior of it. Each one is wound with each individual coil giving off a different value. Now, with all that said, how is he getting more energy out than what he puts in? Some would have to understand this in the nature of the bifilar coil. Some would understand it in the sacred geometry and energy. Some understand it in the frequencies that he's using. This guy has something that's far above everyone else. He's taking every single thing that you would want to get rid of in an energy project, and he's taking it and amplifying it in order to get a result that is much better than everyone else. Let's get into it.
This here is our input. This is 3 outputs from 3 high voltage capacitors with a diode going into each capacitor from 3 separate pickup coils, all being powered from this vortex coil that's 750 feet on either side, bifilar wound in a geometrical form. These 3 meters for these 3 capacitors will show you its output, as well as this light turning on from the back EMF. This is the input. We're running at 27 volts, watts to be determined. We were running from a function generator at 432 hertz, 20% duty cycle, running through a horizontal deflection transistor that goes to the coil itself.
I just want to interject right here. He said 432 hertz. That is an interesting number, my friend. And if anybody is watching this, I highly suggest you go over and subscribe to both Old Man Builds and Gerald's channel. I'm not sure, but Gerald will drop it in the chat. But yeah, Old Man Builds is the YouTube channel you need to subscribe to right now. And let's continue.
Again, this light will be lit from the back EMF, and these capacitors will be filled by the vortex coil on the outside of the coil. All right, so here we go. I'm turning it up. As you can see, that light's pretty bright. We're producing 34 volts on this from this pickup coil, 15 volts from this pickup coil, and 15 volts from this pickup coil. And that's needless to say of the rest. But we'll get to that in a future video. This is just a quick show of what I'm doing and what I've been working on. Our input watts are between 7 and 9 watts at 27 volts. All right, ladies and gentlemen, here we go. You do the math. Video, we got 2 more meters added to this, 2 more capacitors, pulling from 2 more pickup coils. So here's the setup. We got a 750-foot bifilar wound vortex coil with 11 pickup coils around the outside of the coil. We have a single diode and capacitor going to 5 of these pickup coils only, because I only have 5 meters. Alright. The secondary, the back EMF, is going to this light here. We are going to be running 27 volts, and we'll see what the wattage is when we turn this on. The function generator will be running at 432 hertz, 20% duty cycle, and 20 volts per pulse. Alright everybody, here we go. We're turning this sucker up. So these 5 pickup coils are what's on these 5 meters. We have 62 volts, 38 volts, 16 volts, 18 volts, and 13.5 volts, all from a 27 volt input, 8 watts. You do the math, ladies and gentlemen.
It's everything you wished for. Your site track.
Wow. This is truly.
Or we've only seen this.
This is truly the Lord of the Ring.
Coil connected to a few multimeters. That means that the rest of them haven't been accounted for yet. What we're also seeing is where they're placed is becoming important, and the multiplication based on what he's actually putting into it. Sometimes he's getting back EMF. Now, is it just that? Or is it a lot more than that? I tend to think that it's a lot more than that. He's multiplying something in here more than we realize. And the frequency he puts in is just as important as the energy that he puts in.
What do we have here? We have a bifilar wound vortex coil, 750 feet aside, with 12 ferrite core pickup coils on the outside of the vortex coil, all attached to a single diode and a high voltage, high frequency capacitor. We have 5 meters showing outputs from 5 of these coils. I have tested all of them. They all produce roughly around the same voltage, give or take. The secondary on the bifilar wound coil is going to this light right here, which is 4 panels of 94 volts to light each LED panel. It's going to be pulsed with 28 volts from a function generator at 428 hertz, 20% duty cycle, through a horizontal deflection transistor, and then to the coil itself. We'll show you the output, but this is a means to an end, ladies and gentlemen. I'm going somewhere with this, so pay attention. The next few videos in this video series will kind of show you where I'm headed. Alright, so we're going to turn this on in 3, 2, 1. As you can see, the light is, well, almost blindingly bright, and we have voltages from 5 separate pickup coils that are surrounding this core. As you can see, it's running at anywhere between 4 and 8 watts. Pretty interesting output for 4 to 8 watts.
That's a very bright light.
We got a vortex coil with 3 pickup coils on the inside, 1 pickup coil on the outside. The pickup coil on the outside goes to this meter right here. The ones on the inside go to these 3 meters. And then we have a tri-field meter on the outside turned to the magnetic field on the selector switch. We're going to be pulsing 28 volts from a function generator at 880 hertz square wave, 20% duty cycle, through a horizontal deflection transistor and into this vortex coil. The back EMF, or the secondary on this bifilar wound coil, is going to light that light, which we're going to have to cover with our whoppers. Why? Because otherwise you won't see the meters. It's too bright. Alright, we're going to turn this on in 3, 2, 1. Whopper time! All right, what do we got? We got a pinned tri-field meter here. Don't try this at home, ladies and gentlemen. We got 27 volts. We got 90 volts. We got 48 volts. And on the outside, 9.33 volts. All running off of 27 volts pulsed, 0.05 of an amp. 1.5 watts. That's what's running all of this. We're getting full power on our light.
Wow, that is intense.
27, 90, 48 volts on our inside pickup coils and 9.31 on our outside. And our tri-field meter's pinned. Don't try this at home, ladies and gentlemen.
For those,
that is incredible. I'm wondering, Gerald, have you ever tried putting a digital pole detector in the center to see at what happens at lower frequencies? I'm wondering if if he's creating a monopole too. He must be. Either that or no pole, where essentially the monopole is just really small and requires special equipment to detect.
those of you out there that understand the flow of energy and why things are the certain way they are, when you add different components to something, take yourself a test right now. Which one of these meters is connected to which part?
Hey everybody, this is the vortex coil inside of a case, and no power going to the circuit except from the function generator at 880 hertz, 20% duty cycle square wave. And I'm just going to turn up the function generator. There's no power going to the transistor other than the function generator. Check this out. Can you see that? Can you see that? Interesting, isn't it? Alright, quick video. Vortex coil in a case. Pulsed 28 volts from a function generator, 880 hertz square wave, 20% duty cycle through a horizontal deflection transistor to this coil. And we're going to pick up induction. Through induction, we're going to pick up voltage on these 3 meters. Plus, we're going to light this. We're going to see how much watts it takes to do all of that. In 3, 2, 1. All right, so what do we have? We've got 90 volts, 122 volts, 195 volts, and this is running at max. And we're doing all that on 27 volts, 0.04 of an amp, 1.4 watts. Now that the voltages have stabilized, we've got 53 volts, 41 volts, 113, and the lights at max, all running from 1.4 watts, 27 volts, 0.04 amps.
That is incredible. That's a remarkable device right here. This is blowing my mind just how much it's capable of doing. I'd like to see you take this device and power something, with it, I don't know, like maybe a motor or something. That would be interesting.
I told you,
I'm here today to talk about dielectrics.
Yeah, that is really remarkable.
What is a dielectric? Well, in electromagnetism, a dielectric is an electrical insulator that can be polarized by an...
So Gerald says yes, he is creating a monopole, so that makes sense, because when you create the monopole, in my opinion, this is my theory, again, these are all theories, you'd be a bold person to say you claim to know exactly what something is happening, but this is my feeling of what's happening, is that when you create a monopole, you're pinching off the inflow of the magnet you're creating, which magnets have access to aether energy, and you're pinching off that inflow, and you're allowing that radiant energy to flow outward into your system, and it just, like that cold energy just absorbs through everything.
An electric field, kind of like what we do here with this vortex coil.
Yeah, he's definitely got an energy
because of dielectric polarization.
No matter how he has it configured, he's got it in there.
Yeah, it's very interesting because, like it's one thing to have, like my system, it's a good proof of concept, but to actually put it to something practical like this, that's a big step, where he's got multiple devices hooked up, or, multimeters which simulate multiple loads, and they each have like a different voltage, it looks like. So that's extremely interesting, because this could be like basically a central hub for power for houses and stuff, sustainable for people who want to go off the grid.
Yeah, the voltage is in the geometry.
Yeah, he has multiple coils, right? These look like multiple coils within coils.
You have to look at where each thing lines up, where the input and the output of the capacitor is versus where the coil lines up at. It all has to work in sync.
That's remarkable. Okay,
positive
let's continue with the video.
charges are displaced in the direction of the field, and negative charges shift in the direction opposite of the field. So today I'm going to attempt to show you that with a permanent magnet. And then in the next video, I'm going to show you dielectric polarization with a pickup coil. All right, ladies and gentlemen, what we have here is 28 volts being pulsed in, 7.83 hertz at 20% duty cycle square wave. And that's to accomplish the pulsing effect of this light, which is running off this secondary, the back EMF coil, the secondary coil on this bifilar. And it will also show, as it turns off and on, the pulse rate of what's happening to this magnet. Now this magnet, when I started using it, was brand new. It was covered in nickel. After doing many tests with it, the nickel has been eaten away. So let me show you what I mean by dielectric polarization.
What do you mean the nickel's been eaten away? That's crazy. Hold on. Is that normal? So what immediately comes to mind right here is the Hutchison effect. If you know anything about plasmoid clusters or Ken Shoulders charged clusters, they tend to kind of eat away at materials. They transmutate them, take out big chunks and turn them into other things. So that's interesting. I wonder if some kind of Hutchison effect is going on right here with the nickel.
Turning the coil on in 3, 2, 1.
Oh, wow, that's cool. I like that. And look at the light flashing.
And what's happening now is it's pulsing, but it's not polarizing. Now I'll turn up the pulse a little bit. And it's instantly polarized. And now I'm getting more out of the light.
See, I'm starting to think that his coil design might be the superior for power generation in general, just because of how big the inner diameter is compared to the outer diameter. It's a lot more. It looks like it maybe could allow for a lot more radiant energy flow. I don't know. I'd like to build one of these babies.
Interesting. Dielectric polarization, ladies and gentlemen. The first demonstration.
As I went through these videos and looked at every single experiment, I can't help but wonder, how many experiments did he have to do to figure out where everything was interconnected? How many experiments did he have to do to figure out where all the anomalies were? This is pure genius when you can start to take every anomaly and stack them one on top of the other and figure out exactly where the sweet point is in every single thing that you do. It's absolutely genius to watch this. If you can break this down like he is, and you can understand every little part, you can start to see where he's going from here.
Back again, here to do a quick video, short video, call it what you will. Me and the vortex coil. And we're here at the prompting of a friend who suggested that I might actually have the Meissner effect.
What's the Meissner
effect? Well, what
effect?
is the Meissner effect?
Yeah.
The Meissner effect is the expulsion of a magnetic field from a superconductor during its transition to the superconducting state. Superconductor, eh? Room temperature? Possible. Probable? Well, that's yet to be seen. This expulsion that's spoken of will repel a nearby magnet. That's according to the definition on Wikipedia. So there's two types of superconductors. There's a type 1 superconductor, where superconductivity is it's abruptly destroyed when the strength of the applied field rises above a critical value. Well, the funny thing is, if I turn my frequency past, say, 20 to 25 hertz, the magnet stops spinning. Sure, it polarizes immediately, but it doesn't hop around and jump the way that I make it now. It doesn't repulse from the outside the way that it does now.
It's interesting because mine doesn't even polarize. If you go above that frequency range, 20, 24 hertz, it turns from a strong electromagnet and affects, ferromagnetic material to not affecting them at all, at all. So that's very interesting that yours actually still polarizes material above that frequency range. I think that's important to note here.
Now, type 2 superconductors, by raising the applied field past a critical value, leads to a mixed state, also known as a vortex state. Kind of what I've been talking about from the beginning of all this. Now, the mixed state is caused by vortices in the electronic superfluid, sometimes called fluxons, because the flux carried by the vortices is quantized. Now, that's according to Wikipedia's definition. So here's what we're going to do. We're going to pulse 28 volts through a function generator at 7.83 hertz square wave, 20% duty cycle, through a horizontal deflection transistor through this bifilar vortex coil. The secondary on the bifilar goes directly to that light. There's no diodes, there's no full wave bridge rectifier, it's just straight to the light. And the magnet, as you can see, is right here. So what I'm going to do is turn it on in 3, 2, 1. Did you see that, ladies and gentlemen? Let me do that again. In 3, 2, 1.
So the magnet is inducing the electricity in the light because it's, wiggling or whatever, right? I'm assuming. I mean, what I observed in my coil is when I put the neodymium magnet in the center and I spun it, and this is at the Schumann resonance, it produced a big spike. It induced a big spike of voltage on the output.
I'll repeat that. We're going to start again in 3, 2, 1.
Yeah, it looks like every time it taps, it creates that, but I don't know if
Interesting
it's
experiment, I'd have to
the
say.
actual frequency itself being able to be pulsed that's doing it before the magnet moves.
Oh, I gotcha. Yeah, that's an interesting question. I know Gerald will probably have more interesting theories on it, but I really like this coil design. I have a strong feeling, and this is just my gut instinct, that some kind of Hutchison effect is going on with this coil.
The Meissner effect? Well, I'll let you decide, at least till I bring it to my local university.
Well, hold on. If you say Hutchison effect, so you're saying vertical and horizontal fields are going on. Is that what I'm hearing?
So in terms of transmutation of elements and eating away at the nickel, that just sounds to me like he might be creating plasmoid clusters, which is what Ken Shoulders thought the Hutchison effect was. Pretty much, different frequencies inducing cavitation at a microscopic level, and then doing certain things at different frequency ranges. This looks like a much more controlled Hutchison effect, though. Like he has it tuned in to actually be useful for something, instead of just John, who was just like, I think he was shooting random frequencies at things and seeing what happened. Mad scientist.
I don't think he did anything random, to be quite honest with you. I think
oh, really? You think it was
something. I think he found it, amplified it, and didn't tell you. And he just made it look
like he was
different than. Yeah, as someone who can do that, they're going to be able to consistently do that.
You could be onto something, because he has a tendency to not want to release key details of his experiments. So that's probably, that could be correct.
National security as soon as he does. You know that, right? You can't create an energy ball inside of metal and put it out on the internet without the government coming after you.
Well, I remember specifically in one of the interviews, he said that, and again, this could be a lie, but he said that, he doesn't really remember which frequencies that he was using, and the government confiscated all his notes. But again, that might be a lie. He probably just, telling people that.
Nope. I think there's something more there.
Yeah.
There's a point where you get your science done, but then you kind of have to bow to the powers that be if you want to stay alive.
That's true, and I think if I'm not mistaken, I think what happened is the Canadian government stepped in, or and just took all of his research, or was he intended on working with them? I forget the official story.
I know Gerald says he has an NDA, non-disclosure agreement, so
so he was working with them
definitely got
at some
something.
point. Yeah, he was working with them at some point then. Real quick, I'm gonna grab this and I think I'm already subscribed to his channel, but just to make sure. So if anybody is watching, this is Gerald's channel. It's WP Gen Lighten 4, the number 4, Truth, the number 2. Right here. And I was not subscribed, so that's why I was missing out on all this amazing content that you guys should be subscribing to as well. And let's get back to it.
What we have here is basically the same setup with some slight changes. These are all one wire. One wire? They go to a half-wave rectifier, and then the other wire from the coil goes to the ground. This wire here is the ground that goes to a pipe that goes underneath my house. So what I'm going to do here is I'm going to hook up this ground, and you're going to see a couple of meters climb just from being grounded out. Remember, this is a one-wire setup now.
We're just gonna see him live stream one day, and he's just gonna open up a portal in space-time. Something crazy is gonna happen, and I have a feeling that there's going to be a lot of amazing stuff coming from this channel.
It goes from the coil to a half-wave rectifier, then to the capacitor, and then to the meter. So you got this one here, which was climbing to 1.5 at one point. I guess it's not connected right out, I'm not sure. All right. So we have this one and then this one here at 2.6. Now, normally I pulse this circuit with this wall plug, which is 28 volts. That wall plug powers this circuit here, which is pulsed from a function generator. Now, there's no power going into the circuit, and I'm going to turn on just the function generator at 22,000 hertz, square wave, 40% duty cycle. And now it's grounded through one wire of all four grounded to the pipe underneath my house. Only one wire is going to these capacitors. All right, here we go. This one here is at 2.5 because it's lighting this little bank of LEDs. 13.8, 20.2 or 3, 21.6. And that's all from a function generator. Well, let's disconnect this because it's pretty bright. Look at that go up to 26. And as you can see, this is slightly lit, not majorly, but one panel's 94 volts to light. That's from a function generator? Interesting. Remember, it's not plugged in.
Need to build UML diagrams to visualize your code base? Try Lucidchart. It's an intelligent.
What we have here is a bifilar 750 foot wound vortex coil. The secondary is going to go to this light right here, which we're going to pull out of camera because it's bright. This ferrite pickup core wrapped 120 wraps, copper wire, one diode, high voltage capacitor. Then it goes to this battery that, as you can see, is deader than snot. This is a live experiment. I don't know if it's going to charge the battery or not. We're going to pulse it from this function generator through the horizontal deflection transistor to the coil. We're going to pulse it at 1,000 hertz, square wave, 50% duty cycle. And we're going to do it with 27 volts. Well, 28, give or take.
So I got a question for you, Gerald. Do you notice different outputs, or do you notice more output at different specific frequency ranges, or is it just like pretty much everything you oscillate will produce some kind of over unity effect with your coil? Because with my coil, it seems to be like specific ranges output more, and then you go past a certain range and it just dies and kind of constricts the output to be unuseful. Hey Tammy, welcome, welcome. We probably won't be doing too much more of this stream. I'll probably conclude it at 7 or before Eastern Standard Time, just because I want to prepare the system for Free Energy Fridays, a podcast that we so fondly love on Crypto Alchemist's channel on YouTube. So if you are interested in Free Energy Fridays podcast, where we have a whole host of free thinkers and inventors working on different free energy projects and research, join us at 9 o'clock Eastern Standard Time. Remember, that is 6 o'clock if you're over on the California side. Sorry, my headphones are dying. Anyways, join us at 9 o'clock Eastern Standard Time for Free Energy Fridays on Crypto Alchemist's YouTube channel.
All right, so here we go. In 3, 2, 1. Would you look at that? So on 11 watts power,
Jared answered you.
We're charging this battery.
No.
You said what?
He answered you in the chat.
Oh, let's see. Pull it up here. Yes, I get output to a certain point and then it starts to reduce, but that depends on what I'm resonating in the center of the coil. Yeah, okay, so it depends on the material that you're resonating to, because you're not just resonating the load with the conductor, you're actually resonating the material inside, and that, I think, matters quite a bit with what you're doing. That makes sense. But, again, I think, and this is just a theory, and Gerald, you might be able to, experiment and test this theory as well. I think that these coils might be utilizing the phi ratio, the golden ratio, meaning we might be seeing harmonics of that specific original resonant frequency that allows for the maximum output or maximum resonance in the system. Oh, so it is using the phi ratio. Yeah, and specifically that means the Nunez method would be using the third harmonic. Dun, dun, dun. Right? The third harmonic.
Yeah, it's got a lot going on, man. I tell you, it's layer after layer after layer.
This is an onion, man. Is this a rabbit hole for sure?
Oh, yeah, we definitely went down the rabbit hole here.
All right, let's finish the video and see what he has going on here.
Let's see how long it takes to charge it. I've never done this before. This is new to me. Hopefully I don't blow it up. I wish the camera could pick up the ringing that I'm hearing. I'm going to have to do this experiment with my EM meter just to see what kind of a field I'm producing. I'm probably doing all kinds of damage to myself, so ladies and gentlemen, please don't try this at home. And that battery's still charging. And that's from this ferrite core right here. Hey everybody, here's a quick follow-up. As you can see, the battery's holding a charge. Our watt meter is showing 0. We're not pulsing. But yet my infrared camera 5 minutes later...
Disney 313
is still showing the coil. 5 minutes later. I'm going to show you something pretty neat.
Rewind that real quick. The ad messed me up.
Our watt meter is showing 0. We're not pulsing. But yet my infrared camera 5 minutes later is still showing the coil. 5 minutes later.
Wow, that's cool.
I'm going to show you something pretty neat today. It goes to spin, amongst other things.
These are some really cool experiments.
We're going to be charging this battery, and what I've noticed with this battery, and then a couple others that I've been testing recently, is that you have to condition it to bring its charge up. So that's what I've been doing slowly, is conditioning this over the last 3 days. Now what I want to show you is with this. I'm just going to pulse it, I'll turn it on, and I'll let you guys decide. 27 volts, as usual. 1000 hertz, square wave, 50% duty cycle. In 3, 2, 1.
Oh?
I'm not touching that.
Oh, wow.
But what we have here is four cylindrical neodymium magnets on either side. I haven't touched the desk or nothing. That's all from the magnetic fields.
Yeah, it's clearly oscillating with the magnetic field.
Magnets with a hole through it, and there's a pencil and a string holding it up. So let's stop the movement. And they're opposing sides. If I push them together, or try to, they shoot apart. That's the way they're set up on this pencil. So let's see that again. I wish you could hear what I'm hearing, because I'm hearing the Doppler effect.
That's interesting.
Of course,
yeah,
that has to do with resonance.
Right. That's something that I hear a lot, and I've actually witnessed with these, vortex coils is weird sound. Just like, like for me, like for instance, sometimes when I get it at a specific frequency, it just sounds like it's coming from a different spot in the room. It's very eerie.
That's crazy.
Yeah, it is. It's crazy. I'd like to do some more experiments with that.
I make alien sounds with my coils sometimes, man.
Yeah, these coils, man, they do weird stuff. Freak you out.
But interesting nonetheless. Hey everybody, here's the setup. We got 5 batteries that we're going to attempt to charge all at once here. This big battery here.
Oh, here we go, charging batteries.
Snot.
This is the penultimate test, right?
Kind of are deader than snot, really. I mean, they're 12-volt batteries, and I got
tell you a lot about what you got going on.
5 volts over here. I got 5 volts over here. This is the one we've been reconditioning. That's why it's at 12. I got 4 volts over here. It started at 0.7.
Yeah.
And then I got 6.2 volts here. So what I'm going to do is I'm going to pulse it at 27 volts. And I'm going to pulse it at 1,000 hertz. Square wave 50% duty cycle. We're going to see if we can charge them all. Whether they'll keep the charge or not, that's another story.
Right.
All right, in 3, 2, 1. So what do we got going on here? We got 9 volts.
Instantly start moving. Instantly.
We got 12.9 volts, so we are charging.
It's going up.
We're definitely charging.
And that's
In fact,
how many
we're
batteries?
charging all
That's like
5 batteries
3,
at once.
4, 5? Holy crap.
And we're doing it
Oh my god.
off of
I told you,
60
man, you
watts.
got something cool going on.
Yeah, this is really neat, Gerald. This is really cool. I'm not gonna lie, I'm fascinated right now.
Interesting.
You know, it helps watching them
All
one
from
after
that
another
one-
after another, because you really start to get a good perspective on what he's doing. It's kind of hard going back and forth.
Yeah, maybe on the next live stream I'll do that, and I'll just watch them one after another, like you said, back to back.
Well, this is a
Coil.
compilation video, so you got them all back to back.
15 watts, 16 watts. It jumps around in there. But this is the battery that I've been reconditioning. And it's already at 12.7.
Yeah, it's still going up.
Now, holding the charge is another story, but these batteries, like I said, they're so dead, they're so sulfated. If I can even get one back, I will be happy. So I'm going to run the coil for the next few hours.
Well, supposedly cold
and
electricity
we'll do a
will
follow-up
rejuvenate
video.
the batteries to
But
some
as
extent,
you can
right?
see, all 5 batteries are charging all at once
At
from
least in
one
theory.
coil. All from 16 watts.
Yeah,
I don't know
those
about
batteries have to
everybody
be
else
charged.
out there.
It looks like a trickle charge going into them because he divided them so much.
Yeah, that's interesting.
But I'm genuinely excited for July 6th. It can't get here fast enough as far as I'm concerned.
Oh, APEC,
Before we get out of here, I'm going to show you guys what Gerald said to us on the free energy.
That's cool. If this is a conference that's coming up on the 6th?
Yeah, that's the one tomorrow. He goes to APEC tomorrow. Today he does Free Energy Friday. So he's definitely getting his coil out there, but he's been kind of secretive about it. And I mean, don't get me wrong, he's putting out his videos, but I'm just saying, like, the final, like, next step is what we're all looking for.
For sure. For sure. I'm excited. Definitely. And if there's anything online that I can check out, I definitely will tune into that.
Fridays, big shout out to Crypto.
He needs to buy, how many is that? 8 more? I was joking with him on the chat because he got his own multimeter salesman. Because he's got like a whole bunch of them, right? He said he needs 8 more.
Hey, you can never have too many multimeters, I guess.
Oh, man, that's just wild.
Hey, post the best kind of multimeter you recommend for like frequency ranges for current and for voltage around 20 to 30 kilohertz. I don't think I want to go above 30 kilohertz right now, but I need a cheap or inexpensive multimeter that is good at reading current at that level. If you know of any that you can recommend, definitely put one in the chat.
Ask Gerald, because he's got that corner. He got that whole thing cornered. You know what I mean? He got it mastered.
Yeah, because that'll definitely come in handy for phase 2 of testing, because I definitely know that the Nunes method works. It's just a matter of getting the proper equipment for it to work. So
thank you very much for having us there.
Okay.
I'm going to show the video.
I can then show all the 12 coils picking up power. So just imagine this. You're only seeing a fraction of what's going on, right?
Mm-hmm.
If he had multimeters for every one, then just imagine how many more that he has. So if he says he needs 8 more, that's 8 points of power you're not seeing.
Yeah, all this pickup coils. Yep. That's a lot of output that you can attach. That's like a basically like a system, like a power generator. You know, you just plug in your devices. You go on to camping or whatever, and you just plug in your trailer to it, and you plug in your TV and your whatever, and it just, you know, it probably would be good for something like that.
Yeah, but that's what I'm saying, though. He's telling you a number right now, right? And you're impressed by that number. Just wait until you see them all. So.
Oh yeah, it's going to be exponentially large. Yeah, for sure.
It's like he's gonna double this thing.
Mm-hmm. Yeah, that's the thing with not having the proper equipment, though. You know, like I had the same problem. Like I just didn't know what my system was capable of until I could see what was going on a little clearer. You know what I mean? So yeah, that's interesting for sure. We're excited to hear how much it's actually capable of outputting.
You know, I'd like to see is an oscilloscope. And just set up a little transmitter wire.
Mm-hmm.
And let's just put it in the center. And I'd love to be able to read that oscilloscope and see where the frequency spread is. And you can see the amplitudes of things, you know what I mean? Everything like that.
Mm-hmm.
That would be interesting.
Yeah, and I do intend on getting an oscilloscope in the near future for sure, because that's going to be important when analyzing some of these frequencies. You know, some of these signals, and trying to determine, you know, like what the heck is going on with the coil, and maybe finding, you know, tuning it to the exact sweet spot. That's going to be essential, having an oscilloscope.
Yeah. I've had to use mine a lot lately. I don't use a lot of those things on my channel. I like to just show people one thing to the next, but I had to use it a lot on this Tesla coil build that I'm doing, so it's been fun. You know what I mean? I'm going to have to show it all on video now.
Yeah, whenever you get a chance, I'd like to see some of that stuff. I've never personally used an oscilloscope, so when I get mine, it's going to be like, you know, a whole new experience for me. I'm going to have to learn, you know, how to use it, obviously. But I'm thinking about getting something that hooks up to my laptop and then getting Pretty Scope.
Okay. Well, I'll tell you what. Go on OfferUp. Find somebody that has a 3 to 4 channel. You know what I mean? And just buy it. $100. You get a great deal. Locally, pick it up from the person. It's going to save you a big headache. Because buying it new, you're $250 just at the base model. And, you know, you're going to need a frequency generator too. So some have it with it. So you might be able to find a better deal there. I love OfferUp, man. I bought me a little cart for my Graviflyer, man. And it's amazing. So I keep buying things off of there.
Yeah, I'll have to check it out. I'm gonna end the stream because my headphone or my headset is my one headset's dead. The other one's gonna die soon. Yeah, and I'm gonna get ready for Free Energy Fridays. So I hope to see everybody there. Join us for Crypto Alchemists Free Energy Friday podcast, and I will be posting the link in my community tab. For you guys, if you're not familiar with Crypto's YouTube channel. So that'll be in my community tab as soon as I get the link. And everybody, I really appreciate you coming on, Nathan, and having this cool podcast with me today. It was a lot of fun. We definitely have to do this again. And
right on,
everybody,
thank you for inviting me.
Yeah, of course. Anytime. I'm interested in all this stuff. And you guys are awesome guests, awesome teachers. And I appreciate all the people tuning in too. You know, the viewers. You guys are awesome. You always give me good ideas, and you always get the juices flowing in terms of our think tank here. You know, that's what I like to see. So with that, I'm gonna end the stream, and I appreciate everything, and I appreciate everybody. So many blessings, you guys. I'll see you in a couple hours.